All right, good morning. How's everyone doing today? Good, nice. All right, well, we have very exciting talks today. First up, we want to introduce Marius from Geth, who'll be talking about the Don't Let Your Friends Do MEV, right?
Oh, good morning. Now that we're awake, don't let your friends do MEV. Don't let your friends do MEV. Yes. Yes. There are a few puns in this in these slides. Thank you for coming out this early. I didn't sleep very well, so I'm trying to do my best to get through this talk. Yeah, MEV infrastructure. Who here doesn't know what MEV is? Some people, that's really good, because that makes my presentation 5 minutes longer. So MEV, MEV stands for minor extractable value, or recently for maximum extractable value. And the idea is, so for example, I don't know, we have, some of you guys have coffee, right? And if I want to buy 100 cups of coffee from the participants in this room, I would need to pay different prices. Someone would give me their coffee for like $5, someone would give me their coffee for like $10, someone would give me their coffee for $20. So now I want to buy 100 cups of coffee, and what do? I go to all of the participants and I look for the 100 cheapest cups of coffee that there are. So this is how I would acquire my coffee. Now, if I know that someone else is going to buy 100 cups of coffee in a minute, what can I do? I can buy 100 cups of coffee from all of you for the cheaper price and sell it to this other person who wants to buy the 100 cups of coffee in a minute. And this is basically one form of MEV, where you know that someone is going to buy some goods, some currency or whatever, and you slip in right in front of them, buy it, and then sell it to them. And you make up a small difference between the price that you bought it and that you sold it to them. And this has a lot of bad externalities because it means like you as someone who knows how to do this, you can extract a lot of value from the ecosystem. And so because there's a lot of money to be had, to be made doing MEV and extracting value from the ecosystem, a lot of MEV infrastructure has been built over the years. And this is roughly an overview of how the MEV infrastructure looks like right now. So if you run a node, you are the validator. If you run a validator, you can also run a node without running a validator. But if you are a validator, you can either choose to build your own blocks, or you can take advantage of this MEV infrastructure and get some of the kickbacks from people extracting value from the transactions that you're putting into the block. So the validator is connected either directly to a relay or connected to MEV Boost, and MEV Boost connects you to multiple relays. And these multiple relays are connecting you as the validator to multiple builders, and builders might or might not be searchers themselves or connect several searchers. So the idea is searchers and builders are building the block. So they are the ones packing the transactions into a block and making sure that the block is kind of valid. The searchers are searching for these MEV opportunities, so they are looking at the mempool, they are looking at all the available transactions, seeing where is their value to be extracted. And oftentimes builders and searchers are actually the same entity, but sometimes they're not. And then the relay is just there to, the relays are trusted entities, which is kind of bad. But they are here to connect the builders to the validators. Because builders, they don't want to send the block that they've just built to the validator without making sure that the block is actually mined. Because if you send the block to the validator could just take the interesting opportunities that the builders found and include them in their own block, and so steal the MEV. And the relay is there to make this trusted connection. Yes. So there are a few. So if we talk about node software, so your normal Geth or Nethermind, this is all here in the validator. All of this other software is maintained by people that we don't really know, except for MEV Boost. These things, they are still under consensus, so they are very important in, if something goes wrong here, if a block is built in a wrong way, it affects the whole network. But some of the software is not open source. Most of the software in this part is not open source. Some of the software here is open source. But there are advantages of building relays without open sourcing, because you can be the quickest one, the first one. to send the block to the validator. So we have a bunch of infrastructure that is very important to Ethereum, that is not open, that is not maintained by altruistic actors in the ecosystem, but it is maintained by actors that are purely in it for the money. And in my opinion, that's kind of bad. And this kind of shows you, so this is actually the same view that you have here, but turned around. So you can see here a bunch of big validators. So for example, you have Lido or you have Coinbase. And then you have the relays. And the relays are connecting builders and searchers with the validators. And there are relays that are censoring transactions, that will not let transactions through that interact with certain contracts. And there are relays that are not censoring transactions. And because the relay is kind of a trusted entity, it's sad that they are doing this censoring. So all of these games are extremely dependent on the timing. So you have around 3 to 4 seconds to build a block in a slot. And the quicker you are with building a block, the better it is. And the longer you can take, like the longer you, or the more precise you are to get your block up until the cutoff point, where it's no longer, it's too late, the more MEV you can extract. So there are constantly transactions coming in, right? And if you wait longer, you can include more of the good paying transactions. So if you create a block at the beginning of the slot, at time 0, you only have a few transactions available. But if you wait for 2 more seconds, you have a lot more transactions available, and you can create a better block out of this. So all of this infrastructure is extremely time critical. And what some of the relays have allowed is for something that is called optimistic submission. Basically, you as a builder can submit a block to the relay, and the relay will not verify it. It will just send this block directly to the validator. And without even checking that it's correct. In theory, this is okay because the block can be verified by the relay after the submission. And if the block was bad, the person who submitted it will be banned. So you can at most submit 1 bad block. The problem is if this code that bans the proposers is not working correctly, then we have a bigger problem, and we will see this in a few minutes. And you can see here that roughly 20% of all of the blocks are submitted optimistically, and 80% still are verified before they are submitted to the validators, which is the correct way to do it. And another issue that we have is private order flow. Basically, some of the builders have opened up private RPCs where you can submit your transactions. So if you say, normally if you submit a transaction, you put it into the public mempool and everyone can look at the transaction. But if you don't want anyone to look at it, except for the builders, you can submit it privately to them. And you can see that roughly 10% of all transactions never make it to the public mempool. And most of these transactions are actually MEV extracting transactions, but there are also There are also normal user transactions within there. And if you have access to this private order flow, you have a huge advantage because you know transactions, you know all of the public transactions, but you also know some of these private transactions that no one else knows. And so you can build way better blocks than everyone else. And so the issue is if there are entities that are better at building something, that are better at building blocks, they will over time accrue more money, more transactions, more value, and become an outsized part of block building, which is bad. So let's look at some of the issues that we had and or that we're seeing. First up, timing games. As I said, you have up to 4 seconds kind of to build the block. If you're using a relay, it's a bit less because you cannot, you have to factor in sending the data, sending the blocks between the relay and the validator and the builder and the relay. And but you can see in this on the slide on the top, you can see the bits selected by solo stakers, and you can see most of the bits are within the 1 second range. And then you see a validator that is playing timing games, and they are selecting bits that are way later than what the solo stakers are doing. And because they can do that, they can extract more MEV, more fees than the average solo staker. And there's a disadvantage to it. You can only do it up to a point, because if you select a bit that is too that takes too late into the slot, then you might actually miss the slot because you don't get the block out in time. The thing is, if you're a big validator, if you have a bunch of nodes, you can play these timing games better than small validators. So it's an open issue here. And then we have an incident that happened on February 6th this year, where we had 9 bad blocks proposed by one of the relays. And if you remember, in the optimistic submission slide, the idea is someone or a builder submits the block optimistically, and the block is verified after it was sent to the validator. The problem here was, and then if the block was bad, then the builder should be banned. The problem here was the banning code didn't really work because they shut it off, because builders were getting banned for not the right reasons. Basically, the code was so buggy that it produced so many false positives that they just shut it off. So the automatic thing that would, like, if the network was actually being attacked, would protect the network, was shut off because it was too buggy. And so in the end, around roughly 1 ETH worth of transaction fees was lost during these blocks, and the validators have been refunded manually by the Blocks Road relay. But this also shows you, sure, the validators didn't really lose something, but we've seen 9 bad blocks on the network. The network kind of degraded a bit during this period, and so it's really bad, and there's no recourse for it, right? Like, we cannot go to the relay and say, please don't do it. Well, we can, but like, there's nothing stopping them from using this. And then we had another incident a month later, on March 13th, and this was shortly after Dencun, And with the Denkun upgrade with 4844, we introduced these commitments into the block. And one of the block's route relay implementations had a bug in it that would set all the commitments in the block to the same value, basically overwrite all of the commitments with the last value. And here 16 slots were missed, and about 3.21 ETH was lost, but those were also bad blocks. So the bad blocks were mined. Oh, I think it was the other way around. Oh yeah, these invalid blocks, they were already invalid on the consensus layer, so they were reorged out. Kind of, again, this code to check is this block bad was not triggered because the blocks were not part of the canonical chain because they were reorged out. And so, yeah, they have this optimistic submission, but it doesn't really work, and you're not banning the people that are doing bad work on the network, and so we're seeing a bunch of bad blocks. So please, yeah, please fix your code. And again, for example, this relay gRPC, it's not something that we test. It's not something that we test on the test net. It's not something that is tested on with like unit tests or anything. It is made by Bloxroute. In this case, it was Bloxroute, but there are a few implementations, and they're writing their own software, but they're not testing it properly, and all of Ethereum is kind of dependent on them not being bad and writing good software, so it's kind of fun. All right, let's talk a bit about solutions. One of the solutions that is being discussed heavily also now for inclusion in Prague is called inclusion lists. And inclusion lists basically, within inclusion list, the validator can say, okay, I want these transactions to be included. And the builders have to include them, either have to include them or they will just not bid on it. And there are two flavors of inclusion lists. Something that I call the carrot and the stick. The carrot one is a very intuitive one, very simple one, and it's kind of like the nice way of doing it. Basically, you allow the validators to specify which transaction they would like to include, and then the builders can decide, do I want to include them, or do I just not bid on the block? And so builders can still, because there are these censoring relays, right? And there are these censoring builders that will not include some of the transactions. With inclusion lists, these builders can just say, okay, I don't want to include this transaction, so I'm not going to, and I will just not bid on this block. And they will lose funds, they will lose market share, and the people who are willing to bid on the block with the inclusion list will gain market share. And yes, and the carrot part is blocks that do not include the transactions are still valid. So if I say, builder, please build a block with these 5 transactions, and the builder sends me a block that doesn't have these transactions, the block is still valid. So I can still decide, okay, it didn't include my transactions, but the block is so good, it gives me so much transaction fees that I'm still going to include it. And now the stick version, again, validators specify which transactions need to be included by the builders, but they can either be included in the block that is being built right now or the next block. And so the block builders are forced to build a block with the transactions. Or they will lose out on potentially 2 blocks. And so the idea is I as a validator can force my block builder, but also the block builder of the validator after me to include those transactions. And blocks that do not include these transactions are invalid. So that kind of means the inclusion lists are part of the consensus now, and nodes need to nodes need to verify them, and it's not possible to build a block anymore that does not include the transactions. This is a very simple solution, and it's not a part of the consensus, it's just part of this validator infrastructure, so it can be done without a hard fork. This solution requires a hard fork, but it's also kind of a bigger incentive for builders to start, or for relays to stop censoring and start including transactions that they would otherwise not like to include. And this is one of the solutions that's being worked on, and the other one is EPBS, which stands for Enshrined Proposer Builder Separation. And the idea is with this MEV infrastructure, you kind of have this distinction between the proposer of the block, so the validator, and the builder of the block, so the builders and relays and searchers. And the big problem right now is the intermediary, which is the relay. And so as I said, the relay is trusted. You as a validator trust the relay that it will deliver good blocks to you, because you're signing them without knowing what you're actually signing. And the builder is trusting the relay that the relay is not taking away their MEV, their transactions. And EPBS are ideas around how to get rid of this trusted intermediary. There are multiple proposals that are being actively discussed. So I will not go into the proposals that are there right now, but those are kind of the wish lists that we want proposer-builder separation to have. So the builder is sure that if they reveal their transactions, they will also be included and they will get the money and no one else can take the transactions. If reorgs happen, everything is still kind of working. Builder withholding safety means that if someone sends me a blinded beacon block and I sign it, they cannot withhold this information from me. Unconditional payment is I either get to build the block or I get refunded. So I get paid in the end for the service that I provide, both the builder and the validator, and then proposer safety. All right, I think I'm almost over time. So practical things to do: run your own node. You don't need 32 ETH to run your own node to validate the network. You only need 32 ETH if you want to build your own blocks. If you're running a validator, build your own blocks. You don't need to use this MEV infrastructure. Your node itself is capable of building blocks. You might miss out on some of the MEV payments, but you are a good, honest node in the network. If you decide to use MEV, the MEV infrastructure use a non-censoring relay and set a minimum bit on your node. Setting a minimum bits kind of says if the relay, if the block that I'm building, so you're always building a block locally, if the block that I'm building locally is only, I don't know, 20%, 30% worse than the block that I get from MEV Boost, then I prefer to build my own block because I know I'm not censoring any transactions. If inclusion lists are available, opt into using them, opt into your node producing inclusion lists for other nodes, for other validators, and then also get involved in specifying and building this. As I said, with the EPBS, it's still active research, so there's a lot of things going on. And don't let your friends do MEV, and also don't let your friends do LSD. Liquid staking derivatives is also kind of bad. So thank you very much.
Thank you, Marius. Yeah, thank you for the fantastic talk, Marius. Next up, we have Guillaume from, yeah.
Yep. Yeah, no, I mean, I've used it. Right, that happens. Thank you. It's perfect. Okay, awesome. Thank you.
All right, give a round of applause.
Thank you. Yeah, so we did Dankun, was it last week already or 2 weeks ago? Time flies. And now I'm going to talk about Stateless Ethereum, which is a key item on the roadmap, and that is hopefully coming soon. So I'll start, I mean, like many people have today, like at this conference, was reminding you how painful it can be to run homes like a solo staker. So sorry, Marius. It's it's a reality check. To be a home staker, you need to have 32 ETH, of course. But you will also never really know how bad your internet connection is before you run your own node. You don't know how bad your electric grid is before you run your own node. Typically, I would run my solo staker. Everything would be fine. I go on holiday or to a conference or anything, and that's when there's a power cut. So you need either a smart plug, if there's a power cut, to be able to cycle your your PC or your router, because the router also tends to freeze, or a good neighbor, a trusty neighbor that you give the keys to your validator to, I guess. But yeah, generally you need to love DevOps, and you need to love DevOps any time of the day or night. So for example, last week I woke up to, do I have, yeah, okay. I woke up to this, missed slots, and I had to fix this. So yeah, staking is hard. It's if you compare it to food, if you're a terrible cook like me, you're still better off going to the fast food restaurant. But the question is, can we make it easier for someone to eat better food? And so we are coming up with a few ingredients to this end. One of them is vertical trees. This is what I'm working on. There's also distributed validator technology, proposer builder separation. So Marius already covered this, but I will also cover this a little bit. And rainbow staking, that was also mentioned by Vitalik yesterday. But let's start with vertical trees. So this is not going to be a very, very technical talk, but yeah, so to give you the TLDR of vertical trees, what vertical trees allow for are smaller proofs. and smaller, like the tree itself is going to become smaller as a result. And the idea is that the proof is so small, the tree is so small that you can package a stateless view of the tree, like a subset of the tree that is small enough that that you can add it to the block, and when you receive the block, you can unpack this stateless view of the tree, and it contains all the information you need to execute the block. And yes, my finger slipped, but basically there's a lot of very useful advantages to this. It slows down the state growth. It reduces the impact of I/O, which is a big performance killer currently on Ethereum, simply because most nodes will not even need to write data to disk. Everything will fit in RAM, and even for those who like the block builders, for example, they need to write data to disk, but there's less data to handle, so it's an improvement in itself. Because of that, because you live day to day, block to block, you don't really need to maintain all the history, so it will give rise to stateless, some dedicated stateless clients that only support the latest fork, or maybe one fork and the next, and so that will help client diversity. It will also improve like client management, because yeah, you just receive a proof with the block, so you don't have to trust anybody to promise to always give you the proof. It's attached to the block. Because we get rid of the I/O problem, we can maybe, I mean, I don't want to make this kind of promise at a conference, but we could maybe increase the gas limit. And more than everything else, we have a cute elephant mascot, so that's that's a done deal, really. Another aspect that is quite interesting, is going to play nice, is distributed validator technology. So there are two companies that I know of, there's probably more, that are working on this. One of them is Obol and the other one is Diva, if I'm not mistaken. The idea is to pool resources. So it's, you can, instead of having one validator running at your place that you have to maintain, wake up at 4 a.m. to fix when there's a problem, you can share your, you can build a distributed validator with some kind of middleware, and every validator is going to run maybe a different client, or at least help you perform, I'm looking for the word all of a sudden, fault tolerance. So if your connection goes down, your partner's connection will still be up, likely, and so your validator's uptime will be better. So you can also implement what I call like client diversity, which is something that has been proposed by Peter from Geth back in Istanbul. Even if Geth remains the supermajority client, at least before they push a block to the network, they will be light clients to other ELs, and they can verify that there's agreement on what the block is. And if they realize they have the minority share of the block proposed, like they disagree on what block should be proposed, they would refrain from doing this. So it would solve some of the problems of client diversity. But yeah, it's still I mean, it's still in work in progress. And there's also, so I was talking about pooling machines, but you could theoretically, and Obol has written a few smart contracts to this end, you could also share, like pool your ETH together to come up to pass the 32 ETH threshold. But for this to be perfectly secure and decentralized, we need EIP 7002. Which has been CFI'd for Prague. I think it's CFI'd, or is it, right. Okay, there's also proposer builder separation, so you just saw a talk about this topic. But yeah, the idea is that most of the blocks are currently built by very centralized entities, or at least unknown entities. We don't really know what they are. And there's maybe less than 8% of the network that is doing it the way it was meant to be done. So this is a reality, unfortunately. Oops, sorry. This is a reality. We have to deal with it, and if you can't beat them, join them. So maybe there's a way to use this to at least build a better Ethereum. So the fact is that if it's easier to maintain a node, if it's simpler to build a validator, if more people have access to the validation role, it will create, at least it will improve the balance of power. And honestly, just to counter any bad behavior, what you need is one reliable source of block production that you can fall back to. It doesn't even need to be performant. It doesn't need to be perfect. It can have a lot of bugs, but it's just about keeping the potential bad actors in check. And the last big component is rainbow staking. So the idea is that currently a validator is expected to do everything. Maybe we can differentiate or create some intermediate roles that would be available to people or to actors with less capital, less technical abilities, which are called light services in this article by Barnaby. So it creates a place for big, heavy operators. It creates a place for the little guy. So that's a pretty interesting article. I have the link at the end. Right, so in his article, Barnaby told me he mostly thinks about censorship resistance as a task that could be done. And that's my feeling, right? Not what the article in itself says, that you could extend it to other part of the protocol. So you could do something that effectively sync committees do. Just that could be a role that could be done by a small solo staker, maybe serving proofs, serving history. So there's a big design space here. And then there's all the things you could do on top of that. So use history expiry, realize that you could also interact with L2s, account abstraction, portal network, and inclusion lists. So I want to give a few use cases. They're by no means exhaustive. They're by no means well defined. It's just to give people an impression of what could be done. So the first one is basically the DVT example, mini staking pool. You find a group of users, you all get together, you pool your ETH, you pool your technical resources, and then this way we can try to reduce the dependence on the staking pool, because if it's easier to do to build your own custom pool, why would you go to the big actor? So the answer to the question I just gave is LST. You can do restaking, you can do liquid staking, but it could be done. You could create your own token. You could create a standard so that when you create such a pool, you have a token that is standard, that can be exchanged over that can be liquid effectively. So the recipe is pretty simple. You just get a standard internet connection. You have a low power machine. You have vendors that exist, DApp Node, Ethereum on ARM. I say Coinbase because I'm sure they'll get into the business if it makes sense. You don't buy a lot of ETH. You create a contract, a DVT contract with people. You plug it. You forget. Another use case is the sync server. So that's also a pretty broad stroke description, but the idea is because we have stateless, we are going to forget data. I mean, we don't want to forget it forever. We still want to be it to be available in some form, but it doesn't have to be available on every single node. So it makes sense that some nodes could be holding the history and serving it upon request. This is not necessarily connected to rainbow staking. It doesn't have to be subsidized by the protocol, or at least paid for by the protocol. It can be be paid for by a fee. But yeah, we already have some aspects of this that are paid for by the protocol with sync committees. It tells you where the head of the chain is, which is some important part of the sync. You could imagine doing the same thing with the rest of the sync, like serving state, giving proofs, things like this. The main case I was describing of rainbow staking, at least as it's been described to me by Barnabé, was censorship resistance. So you could have light nodes that are in charge of creating inclusion lists, assuming those inclusion lists are mandatory. So that would be the stick part in Marius's presentation. And the heavy stakers, so what we currently think of a validator, would be expected to include them. So this would be a small capital investment, low slashing risk, but also a low reward, obviously, but still interesting. And I think this is the last use case, is the L2 crosslinks. Currently, because Verkle offers smaller proofs, currently you kind of have to go, if you want to use a resource from one L2 on another one, you have to go through the, from one L2 to another L2, you have to go through the L1 to transfer those. There are some companies, I'm aware of one called Lagrange, that try to create cross links between every L2, so skip L1. I mean, the use case is an ENS. You want to prove on one L2 that you have registered an ENS on a different L2. Because you have smaller proofs, you could do this, and you could get some nodes that offer an RPC endpoint, where you would say, prove that I have this ENS on this L2, and make me a proof that is valid on this other L2. So this way, that could be achieved, and I think it would improve the usability. So these are just basic example. It's really very hand wavy. But where I'm getting at is to build this future. We need people like you. There's a Verkle testnet that's already available, so it's got most of the features. So yeah, basically come and play and build a better Ethereum. So that's pretty much it for my talk. I left some links, so the Verkle tree, as well as the Verkle tree information page, as well as the testnet. Some papers from Mike and Barnabé on PBS, and then the famous rainbow staking article by Barnabé. And yeah, that's it.
Thank you. We do have a little extra time if you want to take questions.
Yeah.
If anyone has any questions, feel free to ask. Don't be shy, you can put your hands up. We've got a question over here.
Thank you. Thank you for the presentation. So you run your own nodes. Do you make your transactions go through your own node as well?
No, I mean, I haven't felt the need, but yeah, it would be okay. I assume that was a personal question. In theory, yeah, I could. It's not a problem. But no, I don't. Is there a follow-up question?
No, it was connected to the previous talk to avoid MEV bots and things like that, and but that's more connected to the one before. So that's what I was asking.
Well, this being said, I don't run MEV boosts.
Okay.
Anymore, I swear, I stopped.
Thank you.
Thank you for the question. Does anyone have another question? If not, our next panel will start at... Oh, sorry, I didn't see. We've got one over there.
Right.
So how to make sure Signal correctly store the data?
Sorry, I didn't.
Because you just mentioned that sync node when you want to do the stateless client,
yeah.
And then like some node have to store all the data, right? All the historical data,
right?
And they're called sync node. And I want to know how to make sure sync node store correctly the data.
Oh, well, you would be given a proof that, well, okay. the data, you want the latest data, right? So because the latest block still has all the state, you can prove that even though your data was last accessed a long time ago, it's still present in that cryptographic commitment, that it's still present in the state that is committed to by this cryptographic commitment. And so when you are given a proof, you are given a proof of against the latest block, or at least a recent block. So when you are being served the data, you can immediately check if the data is not only correct but current.
Is it a commitment or is it like a ZK proof?
Both in theory, but currently it's a commitment. It's what we call a polynomial commitment, or a vector commitment, more exactly. So yeah, it's just it is a commitment that represents the whole tree, that is stored in the block itself, and then you open this commitment. You prove that your value is indeed inside this big polynomial.
Right. Thank you.
Was there one more over there, or? If not, thank you very much for your talk. Our next panel will start at 11, so we'll start preparing for that.
Cool.
See you guys in 10 minutes. Yeah, thank you.
Okay. I think. Okay.
Yes, amazing. Thank you. So today we have a great panel on L1s. Our host is Xiao Wei from Ethereum Foundation.
Thank you.
Yeah, please welcome Xiao Wei from Ethereum Foundation. Vitalik, also from Ethereum Foundation. Marius from Geth. Matthew from Lodestar. And Guillaume from Geth. Please give a round of applause for the L1 panel.
Test. So welcome to the ETH Taipei Ethereum Layer 1 R&D Panel. So my name is Xiao Wei. I work at the Ethereum Foundation Consensus R&D team. And these are my favorite panelists today. So, so we have 3 client representatives and 2 from research side. And so like we actually all work together remotely around the world to deliver the sensing, the Ethereum code protocol upgrade. So today, I think the goal of this panel is to bridge the small gap between research and development. And also, like, we want to share the messages that we think they are important. Also, like, exchange the ideas here.
Yeah.
Okay, so Our first question to the panel is, could you give a short introduce of yourself and also share like what is the Ethereum L1 feature excites you the most? I mean the future feature. I will start with V.
I have what? Sorry. Oh, okay. So, sorry. So my name is Vitalik. I'm, the famous Dogecoin enthusiast. I mean, I guess for favorite feature, I'll focus on one that sometimes gets less attention than the others, which is the purge. So what the purge is basically it's a set of changes, the goal of which is to try to simplify the Ethereum protocol, reduce requirements for users and for clients, and basically make both the specification and client implementations simpler over time, and also help make the network more decentralized by reducing requirements and making it easier for people to participate. And I think this is super important because there's constant pressure to keep adding new things and to keep increasing the power and the functionality of the platform, but we also do not want Ethereum to be a platform where requirements and complexity keep going up. There sometimes needs to be down as well. To that end, I think one of the most underrated features of Denkun was the self-destruct removal, right? So now, as of about a week ago, the self-destruct opcode only works if you destroy a contract in the same transaction when it was created. And I personally hope that in a couple of years we can go further and remove it entirely. And the reason why even the first step is valuable is that it adds a new invariant, which is that there is now a hard limit on the total number of changes to the state that can happen within a particular block. And it's proportional to the gas limit, but at least there is an upper bound. In the past, this was not true. And the reason this was not true is because you could have a super big contract, and that super big contract could get self-destructed and then recreated, and then you could read and write state on top of state that was destroyed. And this actually creates a whole bunch of complexity for clients that were trying to keep the state cached to try to deal with. And that's basically hundreds of lines of code that can get deleted now. So excited about that. I'm excited about Geth recently removing a whole bunch of code that had to do with the basically pre-merge proof of work handling, and hope more things like that continue.
Thank you, V. And Marius?
I'm Marius and I like BLS.
Why do you like BLS?
No, to your point about removing stuff, it's so great that we can finally remove some of the code from the different clients. And in the future, if we have history expiry and we don't have the requirement for clients to be able to sync the chain from Genesis anymore, or at least for some of the clients, we can have really nice new implementations of the current Ethereum protocol, instead of requiring everyone to also implement the rules from 10 years ago, and because implement the bugs that there were 10 years ago, because they are enshrined now, and everyone has to kind of implement these weird behaviors before this block, and then after this block it's a different behavior. And so yeah, I'm also very excited about getting rid of stuff. But I actually wanted to really talk about BLS. We are looking into adding BLS precompiles into the EVM, and that is really exciting because right now, well, the consensus layer has been using BLS for a very long time, but BLS just wasn't available on the execution layer at all. And putting BLS into the EVM gives us a bunch of really cool things, like if you're depositing, you can actually verify that that your keys are correct and stuff. That you can verify the signature on your deposit. You can do a bunch of cool things that you can do with BLS, like aggregating signatures. And I think a bunch of protocols are really waiting for BLS to hit. Hopefully we will be able to ship it in the next hard fork.
Thank you.
Hi, I'm Matthew Keel. I'm part of the Lodestar team. And as a JS developer, because Lodestar is a TypeScript implementation, I come from a UX background. And I think some of the most important features in the horizon of Ethereum are simplifying the interactions and also reducing the settlement time. And this is why I'm a big advocate of both account abstraction and single slot finality, which MaxiB is a big piece of. And I think one of the biggest things, while I appreciate a lot of the technical prowess and the difficult problems that we're solving every day, bringing the next billion into the ecosystem, I think is an incredibly important piece of the future of Ethereum, and making it compatible with the thoughts of like my mom and grandma is a big step forward for how the ecosystem will evolve.
Thank you, Matt. And next, Guillaume.
Yeah, I'm Guillaume. I also work for the guest team. I like adding more code so that Marius can delete it later. I work currently on Virtual trees, so that's my favorite topic at the moment. But I'm also excited about ZK EVM. I think it unlocks a lot of cool features for Ethereum, for increased usability, increased freedom as well. Yep.
Thank you. So our panelists mentioned various types of the features. So I want to talk more about the Vertical. So
Who would have thought?
So first, to Vitalik, so people love to investigate your roadmap diagram to find if there are actually the gold in this, and I wonder that I think it really helps to understand what is the ultimate goal or from the small features that will work in the 1 year and what it will grow in maybe 5-10 years. Yeah, could you elaborate about what is the ultimate goal of Verge?
Mm-hmm. Sure. So there's a multi-step roadmap here, of which I think Vertical trees are a very important first step. But there's also a second step and a third step. And the ultimate goal of all this is to make it easier to run nodes, right? So we talked yesterday and today about the difficulties of being a Solar staker, and being a Solar staker requires having a node, and being a Solar staker becomes much easier if running your own node becomes much easier, and it becomes something that has the overhead of regular software daemons, of which your computer already has 50 that you've never heard of, as opposed to something that takes up 3/4 of your hard drive. So that's the first step there is Vertical trees, which we'll talk about, and we have talked about, but the main goal is to reduce the hard drive space required to have a node. That together with EIP 4444, which would require nodes to no longer store all of the history. But then there are also longer-term steps. In particular, the big longer-term step is ZK synarching all of Ethereum, right? But basically wants to get to the point where The block builder would be the one that's actually generating a proof that the entire block, the state root, everything is computed correctly. And any other node in the network only needs to verify a proof, which is an extremely fast operation, can be done in ones or tens of milliseconds to verify that that block is correct. So once we get to that point, then running a verifying node actually will be something that has comparable storage and compute difficulty to the hundreds of other daemons your laptop runs without you ever learning about it. But to get to that point, we do need to still get quite a bit of work done. But fortunately, we've seen amazing progress on Virtual trees, and we've also seen massive progress on zk-VM implementation. So I'm very excited.
Thank you. And anyone want to talk?
He said it all.
Yes.
I actually think one of the advantages that Verkle gives us is not like, sure, light clients is cool and all, but I think the biggest advantage is it makes us able to prove things about the state in a very efficient manner. And this can be used for all kinds of things. I think you talked about L2 bridges, and I think there are a lot of use cases, a lot of protocols that are underexplored that can make use of these state proofs. We have this idea about the light client diversity, where one of the clients is producing proofs and all of the other clients. So you not only run one client, you run 5 clients on your machine. You run one main client, and that is producing a proof for all of the other clients, and these other clients verify the proof. And then at least within the EVM, all of those clients agree. And so we have a way easier way of making sure that no bad block makes it to the network, because or if a bad block makes it to the network, it doesn't turn into a chain split, because you will only attest to the block if all of your light clients agree to it. And I think there are probably hundreds of use cases where you actually want to prove something about the state, but you cannot really do it right now because the state is so large and creating proofs for it is so large. It's not really possible, and I hope with Verkle we can move there.
I'm actually really excited about that as well. So Lodestar has a project called the Prover, and it gives us the ability to actually do full client-side proofs of individual contract state or transactions. And in order to do that today, we are actually still communicating with the EL side and pulling a lot of these pieces as you're talking about. And so Verkle is going to actually pair a lot of those proofs with the transactions, which is going to actually increase the efficiency of our prover. This is something that is actually really exciting to us. So we're something that ChainSafe is doing is we're in discussions with MetaMask at a very high level to explore feasibility of including our light client and our prover in MetaMask. And what does that do is it reduces the need to depend on external providers like Infura or Etherscan in order to do verification of what do I actually have. And so being able to reduce the amount of transmission and CPU on the client side, especially in resource-constrained locations like the browser, it really increases the usability of that feature.
Yeah, and like right now, if you're sending a transaction via MetaMask or via most of the wallets, you're kind of trusting the wallet to do the right thing for you. And you're trusting the RPC provider to send you the correct state. And there are projects out there already that combine this with proofs in the current Merkle-Patricia tree, but it's just not very scalable, and it puts a lot of resource constraint on these bandwidth constraints on these proof providers. So if we can move to smaller proofs, you can do things like whenever I sign a transaction, I want to know that the balance that I currently have is actually the balance that is on the blockchain, for example.
Yep.
And so just getting your balance is something where right now you're trusting the provider to get you the correct balance. And it would be nice if you could, in addition to getting your balance, you actually get a state proof to it that it matches the current state rules. So.
You know, and actually one of the things we've gone even further to do is we can pre-run transactions in the browser fully client-side, but again, it requires pulling sections of the state and sections of the smart contract code and then running it in an EVM on the client side. But having these proofs that are provided by Verkle will actually reduce a lot of that overhead, so it actually makes it feasible in order to basically pre-run a transaction using live state on mainnet before you ever actually have to send that transaction. It's actually a very cool feature.
And so, just to add what you said, like, yeah, I also think like the biggest advantage of Verkle is that it's going to improve trust by an order of magnitude. You're going to be able to prove a lot more that currently you're just trusting people, to be honest. You were talking about resource constraints, so the browser is one thing, but clearly what at least I'm targeting is the Raspberry Pi. All those devices, when it comes to computing power, they're okay. They have a lot of RAM, they have a lot of computing power. I/O is the thing they really fail on, and this is going to offer, I mean, ideally we would be validating on phones. We're not going to be right there right off the bat, but this is a goal, and I think over time it's achievable.
Thank you.
Sorry, another thing. Apologies.
We love Verkle.
Yeah, let's make it about Verkle, okay? Let's. There's a test net, right? I mean, you can try Verkle right now. You can experiment, and I invite you to do this because we want to get some feedback. We want to build cool applications. So the sooner people get on that test net, the better we make it happen.
Indeed. So about the Dencun, the protocol upgrade just happened last 13th, so and last week. So and just 1 week, within 1 week, and also in the past months, that the client teams are very hard working at what will be in the next hard fork. So it's like hard fork, and they sometimes like overlap in some ways. I mean, the features are working in parallel. So let's talk about the next hard fork, which is the Pectra. According to Team Beko, it's called Pectra. And so yesterday, just a couple hours ago, that we made some progress of the two EIPs. So the first one is the EIP 7251, the max EB. That is basically it allows validators to have a larger effective balance. So before that, the max effective balance is actually just 32, and we want to increase that one so that the signature on the network should be reduced as well, and to decrease the overhead of clients. And the second feature is the inclusion list that was mentioned in Maria's talk previously. So I think I don't have to talk much, but it helps the censorship resilience. So I wonder that what do you think about these EIPs? Open discussion. Yes.
What do you think about MaxEB? Why do we need MaxEB? Matthew, you're probably the best one to talk about.
I mean, to be fair, I love the fact that it's just going to reduce the bandwidth for the same reasons. it's easy enough with BLS in order to aggregate signatures. It's a relatively CPU intensive process, but just being able to collect all of the attestations in order to, and to propagate them across the network on a global scale is really the challenge. And MaxEB is a great step forward in order to promote single slot finality.
Do you think that the big validators will start to consolidate?
No.
No?
Honestly, no.
Yeah.
And
I actually had a question about MaxEB because I only had a very quick look over it. Is it going to be possible to merge, like, do we have to exit? If you have more than one validator, do you have to exit and then push everything back? And would it be hard to actually merge validators without exiting?
That would require way more lines of code.
Yeah, but I'm fine with that in code. I'm not.
Right.
Especially on the consensus layer.
Yeah.
Right. So, anything?
Inclusion lists.
Oh yes.
Right.
What do you think about it?
Yeah, I'm gonna rain on the parade here. I think it's important overall. I think it's a bit early to include them now. Every feature has to be delivered yesterday, but I would say we have a censorship problem somewhat, but it's not really pressing as much as other like MaxEB, because we do have some timing issues that would be solved with that. I would say, clearly Vertical because of the disk size and some features. For me, I think it would benefit from more maybe thinking through. I think it's going to delay Prague and therefore is going to delay Vertical, and I know I sound like extremely obsessive, which I am, but at the same time, this is a fork that needs to be taken very seriously. It's on par with the merge, it's on par with 4844. So it's nice to have I would like to keep Prague as small as possible with a lot of usability features, but I'd say it's time to get to work on the big thing as well.
I'll give some. I guess I'll be the grumpy uncle and give some somewhat unsexy EIPs that I would still love to see. So EIP 7623, which puts the floor on the cost of call data of like either 48 or 68. There's two versions, and that. Actually, it leaves the because it's not a gas cost increase, it's a floor. It leaves about 99% of use cases unchanged, but it reduces the bound on the block size from about 1.87 megabytes to like basically 1/3 of that, so about 600 kilobytes, which makes it safer to do things like increasing gas limits or increasing blob counts. Another one is to start thinking about increasing gas costs of operations that are uniquely expensive from a SNARK perspective. This, I think, especially includes the hash functions. I think the worst offender is the hashing that's inherent in the work patricia tree, but we're getting rid of that anyway. But aside from that, like things like SHA-256, like Ketchak and the various other hashes, because for the ZK EVM L1 use cases, again, we need to have very good bounds on how long it takes to prove a block. For a lot of things, the safety is decided not by the average case, but by the worst case. And people really love putting the average case numbers in their headlines, but right now, a lot of the ZK EVM implementations, they're doing really ugly stuff because of the worst case stuff. They have ugly things like basically having to do more centralized sequencing because they wants to have an extra layer to prevent people from putting in blocks that do lots of hashing. And clearly the correct solution to this is to just make hashing 10 times more expensive, right? But we need to actually do it. So that's another. A third is doing the same to logs, and possibly simplifying the hashing in the logs, removing Bloom filters, because at this point nobody uses them and they're expensive, reducing gas cost of logs, potentially replacing precompiles that are currently almost never used with equivalent EVM code implementations, which will definitely increase their gas cost by a lot, but it's like my favorite way of deprecating things because at least it doesn't fully break any application. But there definitely are lots of precompiles that we excitedly edit in because yay the features, and then 5 years later pretty much nobody uses them and they're half our source of annoyance for consensus bugs in some cases. So start moving toward expiring those. So just a bunch of purging and a bunch of limiting.
Do you think it would be do you think it's realistic that this happens in the next hard fork?
For the next hard fork, I think realistically, if we want to add things, we need to add the subset of that, which is one-liners. So I think AP 7623 can, because lots of people are already raising the alarm that 3 blobs is not enough, and I think the only way to the only realistic and way to add more blobs that doesn't depend on amazing new technology is to improve on other guarantees. So that's one. If I wanted to start the whole train of replacing precompiles with EVM implementations, the one I would start with is identity, because the implementation that replaces it is literally less than 10 lines of code. But if it starts later, that's fine, right? But basically, definitely do one-line things. I would definitely not advocate for anything bigger than 1 or 2 line changes, just because the main stuff is so important.
Yeah,
actually, we had a bug in the one line that is the identity precompile, and getting a bug fix for that. It was a consensus bug. It was a couple years back, and getting a bug fix into a one-line precompile is kind of it's not easy.
This is true. I mean, I guess the argument would be this is deleting a precompile, which is easy, but still, point taken.
So why are we so afraid of adding precompile?
Yeah, I mean, I think the reason why we're afraid of adding precompiles, and the reason why even something as seem as common sense as making BLS accessible from the EVM when we already use it for a bunch of other things takes so long is basically we do have these kind of horror stories of yay, let's add this new thing, here are these amazing use cases, and then 4 years later there's no use cases, and then there's hundreds of lines of spec code. Right, so the complete listing is basically RipeMD. So that one was a hash function that was added in order to enable Ethereum Bitcoin compatibility applications. Nobody uses it. Then Blake, same thing, but for Ethereum Zcash interoperability. Nobody uses it. Mod EXP, and intended to enable RSA cryptography-based applications, including Plasma Prime, including a whole bunch of stuff, possibly VDF stuff. The result is nobody uses it, and it's a big source of consensus bugs. Then, identity, but that one was useful, but now we have mcopy as an opcode. Then, I feel like there were, aside from those, I think the other stuff basically actually is the elliptic curve pairing stuff, which we actually do use quite a bit, which is great.
But it would become obsolete with BLS, because presumably all
Indeed.
the ZK. Yeah.
Yes. So with BLS, I guess the BN128 focused precompiles, they would become obsolete in the sense that there are better things, but there's lots of existing applications that would keep using them. But I mean, the time when they'll all become obsolete is when quantum computers blow everything up, and then there's no point.
Do you think we're making the same mistake right now with adding 9 precompiles for the BLS?
That's yeah, it's a good question. I mean, I think there's a value in being pragmatic. I mean, I feel like sometimes the distinction between adding a few precompiles and adding more precompiles is actually not large, because they're basically pointing to just like different places in the same code base. But I mean, on the other hand, like there's times when if you add more precompiles, it ends up exposing more things that makes things harder to change later on. So one very subtle example of this that I can give is when we did the pairing precompiles for BN128, the original elliptic curve, we designed the pairing precompile specifically in such a way that it doesn't output the GT element, which is like the answer of a pairing computation. It instead, like you have to put in a series of elliptic curve, pairs of elliptic curve points, and it computes all the pairings of them, and then multiplies the pairings together, and then checks if the result equals 1. And this is, like one of the important things that this means is that it basically means that clients have a choice of which elliptic curve pairing implementation they build, right? Because there's like actually like hundreds of ways to do, like there's like okay, fine, at least 3 ways, probably more ways to do a pairing, and then there's hundreds of ways to represent fields, and so there's like lots of different ways to represent pairings internally, and if you had to like make them match up on the answer internally, like that would really constrain the like the implementation, and will that actually open up a lot more attack surface for bugs. And actually, it would have also prevented a whole bunch of optimizations because there's actually some optimizations you can do to pairing checking when you can guarantee that lots of pairing computations are being done at the same time. So yeah, lots of lots of these kind of subtle things where you can end up dodging a lot of bullets if you open up less functionality at the start. And so this is just like one of the things that's really valuable to be careful about.
So, I would also like to answer the question about why we don't like precompiles, or why we don't like precompiles as much as maybe the L2 people like precompiles. They really love them. So you're already kind of mentioned it. So we have the mod x precompile, which does x to the power of y mod p. And within this precompile, I think almost every client actually had a bug at some point. I know that we, within Geth, had 3 bugs, at least. One was in the Go standard library, where you put in some certain input, and it would just panic with the error message, impossible. Turns out it wasn't impossible to hit this, so we had to fix the standard library. The other one was if you put in a really, really big modulus that was even, then it would just take extremely long to process the block. And we were like, okay, sure, what's happening? Turns out in the Go standard library, they have this nice little switch. If the modulus is even, they use this one algorithm. If the modulus is odd, they use this other algorithm. No one ever uses mod x with an even modulus. Like, why is this even possible? Because everyone uses mod x only for like cryptography, and for cryptography you always have a prime modulus, or at least an odd modulus. So no one ever did any benchmarks with even moduli. And yeah, we again had to go into this Go standard library and create a new algorithm for even modulus for modx. And the other thing is, like, that is one bug that I think I found at least like 3 or 4 clients. Because it's like the fuzzer usually finds this pretty quickly, and no one really thinks about it. With a mod x precompile, you basically have 6 fields. You have base, exponent, modulus, and then you have the base length, the exponent length, and the modulus length. If you specify the zero modulus, then the result will be 0, because anything modulo 0 is 0. But what happens is you can specify like really big numbers, and the computer will crunch them, and then in the end apply the modulus, and it will be 0, and so the answer will be 0. And it's just like there are a bunch of times where clients just ran out of time because of this. And it's been in like most of the implementations.
Yeah, so as the author of the ModX precompile, I apologize.
I like how Marius reveals critical vulnerability in the public setting like that.
So we have like some different preference of what EIPs, what features we like. But in reality, that there are some other considerations, like for example, like timeline and what are the users like. And how would you describe your preference based on your considerations? Like, what are the factors that you would prioritize?
So for me, I think security is the most important one by far. It should be. We should try not to create too many foot guns for people, so that they don't shoot themselves in their own foot. For example, the self-destruct create 2 thing, that was kind of a foot gun, where you could, everyone is under the assumption that the code that a contract has cannot change. But now we have this paradigm where you can change the code of a contract. And so it's very important, if we evaluate new EIPs, to think about, does this change the mental model that people have? And, or does it introduce some new denial of service stuff? Like these technical considerations, but we also have to take into account some of these more, I would say, soft considerations about, like, what are people thinking about it?
That's a really good point.
And yeah, you mentioned your grandmother, right?
Exactly. Or even something like IL. This is a feature that is relatively, at least from our CL side, easy to implement. But what are the human implications and the user implications of bringing IL into effect? Like, is it just going to whack-a-mole style open up a new market for ILs and just create a new version of MEV Boost? And I think that's not really a technical challenge. I think that's more of a usability challenge that requires more study, just from seeing how the market is going to uptake this new EIP.
Yeah, I mean, usability is definitely a big factor. I would say there's also how you don't take the whole house by removing a brick or adding a new brick. So we have, I mean, unlike many other blockchains that have projects that have a higher delivery speed, we have already a lot of value logged. We already have a huge user base, and we unfortunately cannot move as fast, and it's a pain. But it's also extremely important because there's a lot of people depending on us. So yeah, that would be another criteria.
So,
Yeah, you.
no, just it's like a very big product management and we have to balance between like decentralization and also the technical consideration. Yes, and I think like sometimes for us on the stage that we prioritize security, but I think we all cherish that as the most important for the network. We have to be responsive to the users.
Yeah.
And I mean, it's like
it can be a challenge because sometimes you have these proposals that are very short-sighted, that are made by some company that I don't know, develop some product and they really, really, really need this one feature.
I see.
And it's just kind of like we will be stuck maintaining this feature forever. And that is a big problem. And this company might be out of business in like a year or two. And we have the same thing with we have the same problem with Geth. A lot where like people show up, propose some feature, maybe even write the code for the feature, and then we merge it in, and 3 years later we want to like refactor something or something doesn't really work, and then we cannot do it. We cannot go with our new ideas because we have this one feature that like 3 people in the world depend on, and we cannot get rid of it. So it's always
Right.
we need to evaluate the proposals very carefully.
How many guest folks like you can you daily talk to? Like
I think it's roughly 9K or something, 9,000 forks on GitHub. Most of them are not like other L1s. I think so. The big gas forks that are actively maintained, probably like 10, 15. But I don't know.
So it's like a much more energy and liberation of the. You have to talk to them, and for the maintenance, it worth your time in the features
it's sometimes sad that there's too little collaboration. There are sometimes you go to a conference like this and you talk to someone who knows exactly what you're doing. Like they know like what everyone in the team, what their role is. They know exactly what is happening, what we're working on, and yeah, they sometimes know the features better than you know them, even though you're working on it. And there's a lot of knowledge about, especially about Geth, in the community. But unfortunately, it's very rarely that this really helps us and that this comes back. So we would love, like, it's great, from my point of view, it's great that Geth has been forked so often and that so many people know how it works internally. But it would be really, really nice if some of that knowledge came back to us. So if you are working on a Geth fork, if you are maintaining a Geth fork, and you find something, you find an issue in Geth that we didn't see, report it to us, send it to the bug bounty program, get in contact with us. If you found some cool new optimization that you did in your fork, upstream it. We very heavily depend on the community to help us with new ideas.
So power collaboration in the open source community.
Yes.
Yeah, I think that's also that's a really good point. And I as a newer core dev, I'd like to say thank you to all you guys who have laid the road ahead of me, and I now get to carry that flag forward. But I think this is a great opportunity to ask the community, you know, because we say thank you to you guys all the time, and I think it's really important that we say thank you again. But like you're saying, there is this fractioning of the space, often sometimes for not within that Web3 ethos. That I think it's a great opportunity for us to say, please come back and give us feedback. And we not only are always there on Discord, we're always there in our, you know, at the community events. We love to hear from you. And it's really important for us to get that feedback because the usability of the system is really key. and we're building it for you. And so understanding your use cases and your challenges and what other opportunities are out there, I think not only helps us to build a better ecosystem, but to really build the best product that's possible.
Good. So as a wrap up, could each of you share like one vision that keep you motivated to continue your current work?
Just one? Yeah, I mean, I would say, it's easy to get depressed when you look at all the bad news in the world. I think we have a truly unique chance of building something that is going to last forever. There's this talk by Danny Ryan at Bogota 2 years ago now, where he said Ethereum is the intellectual gravity well of the entire space. There's a lot of things happening. I would not be able to pick a single feature. They're all awesome. Most of them will never happen. There's so many ideas that fly by and come back and disappear and so on. I'm going to say ZK. Everything ZK related is awesome. If we could just improve the security, the privacy, the censorship resistance, I think it's going to have a huge social impact. But yeah, I wouldn't be able to pick a single one.
I'm going to fall back on account abstraction and lowering the burden of uptake by the next billion people. I think in order to lever this technology for everybody, I think is a huge opportunity in order to really grow not only the appeal but the usefulness of this amazing thing that we've built.
I think to be in this space, and especially in the CodeDev community, you have to be extremely self-motivated. Like, it's way easier to make 10 times as much money doing DeFi or doing MEV or doing some ICO or whatever. And yeah, I think the vision of the future is what kind of keeps us in this space and keeps us building for something good. Like, I don't want to be associated with business models that extract the value from their users. I want to work on stuff that actually brings value to people. I want to work on stuff that I think for the longest time, companies have extracted a lot of the value from normal people, and I think Ethereum and blockchains are a way to give back some of the power to the people, and I really like that. And the other thing that I really like is that we did the merge, and we are not as energy hungry as some other orange people in the space anymore. So yeah, that was it was a passion project, and I think all of the people who worked on it worked day and night because they saw this vision of the future, and the vision isn't there yet. You have a great quote about the Internet of Money shouldn't cost 50 cents per transactions or something. And like people
the orange people laughed at that one for 5 years.
Yeah, and people clown on it, and I think it's this like this is it.
Yeah.
This is the vision. Like, no, it shouldn't, and we're not there yet. And we need to keep building until we are there, until we can provide cheap transactions forever, and not like burn out within like 5 years or something because no one is able to verify it anymore, and you have to have these huge servers to compute anything. No, we have to build a sustainable future where everyone can transact, and everyone has the right and the freedom to transact however they want, and that's I think that's what keeps me motivated.
That was an awesome answer.
Thank you.
Yeah, I mean, I think in addition to the the money and finance aspects that get highlighted all the time, I mean, I see Ethereum as being like one of the standard bearers of the open source movement, and that's something that I have highly valued since like long before I was part of the cryptocurrency space. I can still run Linux on this laptop. It's my laptops have been running Linux for about at least 15 years now. Continue using various open source tools, and always still keep my music in MP3 files. Like always appreciate things that are actually hackable, that actually work with standards, that don't try to keep locking you into all kinds of proprietary ecosystems. And I view blockchains as being one of the extensions of that whole space of values to software that requires collaboration. So to software where it fundamentally is not just a thing that you can do on your computer, but where it has to involve some kind of persistent interaction between a very large number of users, right? And if you don't do that with chains, then the only practical way to do that with servers. And we see what happens when our basic infrastructure and our basic ability to interact with each other depends on servers. So I look forward to building a future that is not just that.
Thank you so much for coming to ETH Taipei, and thank you for the panel. And okay, that's it. Thank you.
Thank you.
Yeah, thank you.
Thank you. All right. Hello. Sorry. Oh, it's working now. All right, thank you, everyone. Thank you, speakers. What an incredible talk. Very motivational and a reminder for why we're all in this space. For now, we're going to close for lunch, and so please grab your free food in Building G. And if you guys can all come back at 1, that is when we were going to continue having more of our talks and panels and the rest of the workshops of today. Thank you, everyone. All right. Good afternoon, everybody. Today we have a bunch of very exciting talks and panels. Next, we have Soraya from Web3 Foundation Grants. So if you're building, you know who to talk to. Give a round of applause for Soraya.
Thank you. So I am Soraya from the Web3 Foundation in Switzerland. Me, myself, also live in Switzerland. So the Web3 Foundation, many people are always asking me, what is actually the relationship between Polkadot and the Web3 Foundation? So I just want to talk about that briefly. So Gavin Wood, which is one of the co-founders of Ethereum, actually came up with the term Web3 back when he was working on the Polkadot white paper, and that's why he created the Web3 Foundation. And that's also the entity that organized the token sale back in 2017 for Polkadot. So this is why the Web3 Foundation is very much focusing on Polkadot technology and Web3. So first of all, I want to give you a quick overview of what to expect. So mostly I will be talking about Polkadot 1.0, so that's the current state of Polkadot. Then I will introduce you to some features that are upcoming in the near future, so still Polkadot 1.x. And finally, I will briefly mention Polkadot 2.0, which is more in the distance and more visionary. So Polkadot is actually more than just a blockchain, because per definition it is 45 blockchains currently, so it's a whole network of blockchains. And the way it works is that you have all these layer 1 blockchains that roll up to something that we call the relay chain. So that's basically the main chain that connects all the parachains. So they just commit the state root to the relay chain. And then they get something that we call shared security. So all these layer 1s, they actually don't need to have their own huge sets of validators. They just need like a handful of them, because the relay chain is secure, and because they roll up to the relay chain, the whole network is actually secured. So that is made possible by something that is called Substrate, which is part of the Polkadot SDK. So that's a framework for developing app-specific blockchains in Rust. So all these parachains actually are written using this framework. Another thing you can do on Polkadot, you have cross-chain messaging. So we have a format that is called XCM. Currently we have an average of 2,000 transactions per week, and there have been over 500,000 of transactions in total that have been sent back and forth between different parachains, and the relay chain, and so all these parachains, they do very different things, like they can be DEXs, there's one that focuses on integrating Bitcoin, there's DeFi stuff, real-world assets, DIDs, fundraising platforms, so all kind of different projects on this network. It has proven to be very scalable and reliable, and so there has been a project called the Ordinals that's like a Polkadot encryption project, so similar to what was going on or still is going on Bitcoin. And during the peak in like December 2023, there have been more than 1,000 transactions per second and millions of transactions per day, and the network did a good job managing it, so we didn't have any problems. And it wasn't even enough for the fee adjustment algorithm to kick in, which is supposed to kick in once the network gets like too digested. Yeah. So another thing that you can do on Polkadot is OpenGov. So OpenGov is our on-chain governance system. It is arguably the world's largest and most decentralized DAO. So and there is also a treasury that is managed by this DAO. Currently, it holds around or more than 38 million dots. So that's currently around 350 million US dollars. And yeah, whoever wants to contribute and be compensated for that can hand in a proposal, so suggest what they want to do, and then the community is going to vote on it using their tokens. So that has already been live for a while, and that's also working great. And another thing, another good use case for that is the technical fellowship. So those are a bunch of core developers, and they are actually getting paid through the treasury. So it's not like a centralized entity paying them, and also they don't have to do this for free. So they get compensated by the network and the treasury, and they even have a sophisticated ranking system. So the more reputation they build, the more they contribute, the higher their rank goes and the higher the salary goes. And that's all on chain, that's transparent and managed by the community through the something that we call the collective system chain. So we have these system chains or common good chains, and other system chains include the asset hub that is more concerned about hosting assets and bridging assets between different networks, and also the bridge hub. Right. Then the next thing I want to talk about is forkless upgrades. So if you build on Polkadot, you will be able to do forkless upgrades. That's in contrast to other blockchains where you have to update your nodes with the new version of the node program. So that's not necessary on Polkadot because first of all you have on-chain governance, which allows you to propose protocol changes. So you would propose a new runtime to be deployed, and then once the community approves it, it will be automatically rolled out on the validators. And from a technical point of view, that's possible because Polkadot and all these parachains, they compile to a WASM binary, and this WASM binary is actually part of the blockchain state. So because of that, once you vote, it will be automatically installed onto so that the WASM binary is going to be replaced. and then the node already runs on the new version of the runtime. So that's a very powerful feature because also it avoids forks, hard forks, which split the community. I guess the only downside I can see is that you cannot have there are a lot of frequent updates, so you're not going to have like huge launch parties for like a huge fork that succeeds. But I guess that's a good trade-off to make. And also we have the Kusama network. So Kusama is the sister network of Polkadot. It's more experimental than Polkadot. So one of the slogans associated with it is expect chaos. So the delivery pipeline usually for parachains and Polkadot is that first they would deploy on a testnet before they would then deploy in Kusama, which is the canary net. So, hello? Oh, okay. So actually there is economical value on this network. It's not just worthless tokens. So you can also make economical experiments, and it's not just limited to like technical testing. So that's also something that is quite unique to Polkadot, I think. Then finally, if you choose to build on Substrate or the Polkadot SDK, but you do not want to leverage all these benefits, because maybe it doesn't fit your use case, maybe you have some reason to do it differently and you don't need shared security, then something you can do is you can run a solo chain. So then, of course, you will be responsible for creating a consensus algorithm and a validator set that is safe enough for your users. But that's possible because this framework is very flexible. So here's a list of different projects that actually use Substrate. Some of them are still work in progress. Some of them have been rolled out. Some of them have even hundreds to $1 billion of market cap evaluations. Yeah. So that's it for the first part. So this is what Polkadot currently is. In the next part, I'm going to introduce you to some upcoming features that are already being tested and rolled out. So first of all, asynchronous backing. So backing is the mechanism for rolling up the parachains to the relay chain. So to connecting the two and making sure that it's safe. Currently, this is done in a synchronous way, and this process takes around 12 seconds actually. So because the block time on the relay chain is 6 seconds, it means that it takes 2 blocks to be secured. So this is what I mean here by synchronous backing. So once the backing is over, you can start backing the next block. And with the new model, it's going to be possible to do this asynchronously. So before actually that block is fully backed, you can already start backing the next block. So that way we can double the throughput because, yeah, as you can see, it only takes, you can do 2 blocks in 12 seconds rather than 1. And also what it allows us, or what allows the nodes on the parachain side to do is they have 4 times more time. So instead of half a second, they now have 4 seconds due to several optimizations to suggest the block that will be included in the relay chain. So if we multiply these 2 factors, we actually end up with 8 times more block space. So this is how Polkadot is going to scale better by 8 times in the very near future. So this is being tested and being rolled out. Most of the code exists, but yeah, it's not fully live yet. And then another feature that is upcoming is agile core time. So core time is basically just the word for block space on Polkadot, right? So Right, the definition is that one core equals one parachain. So if you, as a chain, have one core all the time, then you can be secured all the time. In the existing setup, how it works is that you will have to go through an auction, and you will have to win the something called the parachain auction that secures your connection to the relay chain for 2 years. But this is going to be much more flexible with the new model. So it's going to be possible to fractionalize the core into flexible time frames. So you can even just purchase, you can either purchase in bulk for 28 days and then do another 28 days, or you can resell them into the market or purchase from these second market sellers that purchase bulk core time. So that way you can buy up to just single usage even cores. So if you just want to secure your parachain less often and make it cheaper but less secure as a trade-off, then that's something you can do, and it will allow the projects to be much more flexible, and it will lower the barrier of entry. So I expect a lot of more projects to come to the Polkadot ecosystem due to this new feature and improvement. So the marketplace is going to be NFT based. We already running out of time. So then we also have the Defi Lite client. So that's going to make it possible to bridge Polkadot to the Ethereum network, and that is made possible by creating kind of a compatibility layer for the two networks to make their signature schemes compatible, because they use different block signing algorithms. There is an implementation called Snowbridge, so they are in the process of building this bridge, and they're going to use this Defi Lite client that is just, it's a Lite client deployed on an Ethereum smart contract that then connects to the Polkadot network. And the Snowbridge side on the Polkadot side is going to live on the Bridge Hub. So one of the system parachains that I mentioned earlier. Then just very quickly, so what does the future, the distant future look like? Polkadot 2.0, it basically will be a ubiquitous computer that is running in a safe and decentralized way, and that allows you to execute pretty much any program. And it's even possible to execute it over multiple blocks. And this is actually gonna be, or that's the current vision at least. Jam is going to make that possible. That's something that, a concept that was introduced by Gavin Wood last week at Sub-Zero in Bangkok. So it's pretty fresh, very fresh idea. But I don't really have time to go much deeper into this, unfortunately. If you want to learn more about this, then we have RFCs, and the fellowship is mostly maintaining them, but everybody's welcome to contribute, so you can check this out over here. I will also share a QR code with the link to the slides later. So finally, last slide, how can you contribute? So we have different funding programs. The Decentralized Futures program, it runs until the end of June this year, so it's a limited amount of time only, and it covers around 65 million of funding in fiat and DOT. And then we also have the on-chain treasury, as mentioned earlier. $350 million there, denominated in DOT only. And then we have the W3F grants that has been around already for like 5 years. We have signed over 600 grants. That program is denominated in fiat, so not in DOT. And it focuses only on technical implementations, open source implementations, whereas the other two programs, the treasury is not really a program, but the other two funding mechanisms, they are more versatile, so different kind of projects can be supported there. If you want to learn more and get educated about Polkadot, and there's a EDX course, and there's also the Polkadot Blockchain Academy that took place in multiple times already. This year it was in January in Hong Kong, and then the next edition is going to be in Singapore in May and June. There, the students learn everything they need to start building on Polkadot. And then we have some other programs that help with like decentralizing the community. So the Decentralized Voices is a program to amplify the voices of smaller dot holders that are very engaged and motivated in the community. And it's very similar for the 1,000 Validators program. So that's also for people who do not necessarily have like huge amounts of funds to run their own validators and have a huge stake. So that's how people can support it there. Okay, so with that, thanks a lot for your attention. Thank you.
So we have some time for questions if anyone has anything to ask. Here's one.
Hi, thank you, Nazrin. So Kusama, that's pretty unique, right, with how Polkadot approaches things, and it's been running for some time. So what are your reflections on having this incentivized canary network? Would you change anything about it, and what has been great about it so far?
You mean just from a macro point of view,
yes,
right?
Yes.
Yeah, I think so. Honestly, the auction model to get this parachain slot, it was kind of difficult for smaller projects to build on Polkadot because you had to have a lot of stake. So in some of these auctions, these slots actually sold for more than $1 million or multiple $1 million. So of course, not everybody has that kind of money, right? And with Agile Core Time, we can make sure that pretty much everybody can build on Polkadot. So obviously there is a trade-off because you compromise on security if you choose to not secure on every block. But I think it will massively lower the barrier of entry for smaller projects. Yeah.
Okay. Does that mean that with Agile Core Time, Kusama is slightly less necessary?
I wouldn't think so because it's kind of the playground, right, to battle test the code and also incentives before they're going to be deployed on Polkadot. Yeah.
Thank you.
Thank you.
Thank you. Do we have any other questions from the crowd? All right. Well, thank you very much.
Thank you so much.
In a few minutes, we'll have Kathy from Oro Protocol joining us on stage. So stay tuned. We'll be starting in 1 minute. If everyone could please start taking their seats, we are going to start very soon. All right, we're going to start with the next talks. Next, we have Kathy from OR Protocol. Previously at Ethereum Foundation, has worked on ZKML. Please give a round of applause for Kathy.
Right. So thanks for the introduction. I guess now everyone is wondering how it got from CKML to tokenization. I will actually do a transition, like how does it one step at a time get to this point. So I'm totally not abandoning CK or CKML, if anyone is wondering. So today, we're going to talk about first about on-chain AI. Right? So if we want to talk about tokenizing open source AI, first we need to have AI on-chain to do so. So with that, we're going to talk about two research initiatives at Aura, which is OPML and OPI. A lot of abbreviations, I know, but we'll explain them one at a time later. And then we'll talk about like what are the problems that AI companies or Web2 are facing, and how we propose a solution, which is called IMO, yet another abbreviation, to solve it. Right? At the end, I will talk about like what Aura does in all of these fronts. So first of all, I would like to say that although a lot of people, when they think about verifiability, they immediately think of ZK, right? So ZK EVM means verifiable, but at the same time, we also have optimistic rollup. And my personal take is that actually verifiability is a spectrum, right? So it's not saying that OP or OP rollup are not verifiable. It's actually just as verifiable, but in a different way and a different degree. Right? So on one end of a verifiability spectrum, we have ZKML. So how many of you have heard of ZKML? Okay. So this is the topic I spoke about at ETH Taipei last year. Right? So zero knowledge machine learning, meaning you put machine learning into a CK proof, such that you can have a proof of that computation or a proof of that machine learning inference. So at Aura, we actually published 2 preprints on 2 research initiatives, which is optimistic machine learning. So you can think about that as the OP counterpart of CKML, right? So we have CK rollup, OP rollup. We also have CKML, OPML. So on that far end, it's guaranteed by an optimistic system. And then recently, we have also published a research, which is, what if we bring the best of both worlds? What if we do some part in OP and some part in CK? Right? Obviously, you can't do that for an EVM, but you can totally do that for a machine learning model. So let's take one step at a time how we get to like all these different verifiability. So CKML, as we know it today, we do it for 3 reasons: for verifiability, for input privacy, and also for model privacy. I put an asterisk after the 2 of them because in my OPI paper, we actually talk about how these properties of privacy is not automatically guaranteed by CK. Because of the very nature of machine learning. We won't be diving a little too much into details of these 2, but if you're interested in how that might not be true for CKML, feel free to read the paper. So some of the known issues with ZK and CKML in general is that, well, proving something, especially in machine learning models in CK proof, is memory consuming, time consuming, and most importantly, only for small models. Right? So unfortunately, the size of ML models that can be proven by CK right now is pretty small. Given unlimited hardware and I guess unlimited time, yes, potentially we can prove any model, but right now, that's the size of models that we're talking about. I will elaborate a little bit more on what are the sizes we're talking about in a bit. So then we propose OPML, which is optimistic machine learning, right? So using game theory, which is incentivizing challengers to challenge, along with machine learning on the blockchain. So the good thing about optimistic machine learning is that you can separate execution from proving, right? So not until a challenge happened, you don't really need to submit a fraud proof. There's also an iterative fraud proofs procedure as well as an on-chain arbitration. And with OPML, the size of models we can do are currently Stable Diffusion and Llama. This is the 2 models that we provide on-chain right now on Aura. But it doesn't stop us from doing just any size models, right? So Grok just came out last week. Actually, there's nothing stopping us from putting Grok because it's an optimistic system, right? So pretty much the time and the memory is almost the same as a native execution time for the machine learning model itself, right? And when I meant that the CKML models are small, well, they're not that small, but we're talking about something like GPT-2 or NanoGPT, where the parameters are in the millions and or the small, like, well, small billions, right? So that's the difference of model sizes we're talking about. And so that doesn't really stop us from thinking, okay, so we have OP, which is like there's no privacy because everything has to be open source and transparent. And there's ZK where we can't really fit big models into this ZK proof. Well, what if we combine them? So that's when we, I'll come back to this later. This is when we came up with the idea of OPI, okay? So if you want to look up what it means and why this graphic, feel free to look it up. And so OPI stands for Optimistic Privacy Preserving AI. So essentially what we're doing is we're going to put part of the model, essentially the model where the money is at, into ZK and run the rest in optimistic, right? So you might ask, what does that mean? So let me give a very concrete example so does everyone know Stable Diffusion? Okay, and pretty much all of you have heard of something called fine-tuning, whatever that means, right? So fine-tuning basically means that, okay, we take an open source model like Stable Diffusion and change part of the weights, right? And these changes happen at very specific layers in this in this large neural network. So essentially what we can do is, what if we just put those parts into ZK, right? And the rest is open source anyways, and it's not changed, and everyone already knows the weights of it, right? So in that case, by applying ZK selectively, then we can actually be able to potentially bring really huge models on chain without having to do like a very huge proof, right? Because we're selectively only applying CK proof to those layers. And we're making use of the efficiency of OPML. So speaking of efficiency, let me go back to this slide. So how efficient are we talking about, right, when we talk about an optimistic system or OPML? So right now, first of all, it's already available on smart contract. So essentially, what you can do is you can make an inference call, and our AI oracle will make a callback of your result. And this, the security assumption of this is only 1 out of n honest verifier, right? So as long as 1 out of all the nodes in your network is honest, then this system is secure. And it's 1,000 times cheaper, or this is actually a very conservative estimate. The real estimate is probably more like 10 to the 5th to 10 to the 6th times cheaper than CKML. Right, so now we have all these kind of on-chain AI primitives. And one of the major questions that people usually ask is, what do we do for on-chain AI, right? Like, why do we need on-chain AI? What can AI do for blockchain? This is not the question that is concerned today. The question I am concerned today is actually the other way around. Okay, so everyone asked the first question, what does AI do for blockchain? Why do we want AI model onto blockchain? Why don't we flip it the other way around, which is, what does blockchain do for AI? So I'm gonna see if this plays. So how many of you have seen this video somehow? Okay, does anyone know who or what generated this video? Sora, exactly. So this is a video from Sora by OpenAI, right? So what do you think if you are an AI company doing video generation, as soon as this comes out, or you're a startup founder doing like AI video model generation, video generation model, what do you think the problem would be as soon as this comes out? Sorry? Right, so first of all, fake videos, but from the founder of a video generation model. Right, so this is some of the problems that AI industry is facing, right? So first of all, you have a closed AI dominance, right? So they are fully closed source. You don't really know what to do and how to really outcompete them, right? So, and also there is, you know, with OpenAI, if you have ever used ChatGPT, you probably have realized that the performance drift. So this is called a model drift or LLM drift, which is the model slowly changes its quality. In a good way or in a bad way, but usually in a bad way, right? So it has more and more glitches. It's getting weird, giving out weird response. So this is sort of why we need verifiability in a way, right? So how do we verify that we are getting results really from that model? And how do we verify that they didn't just randomly change the version of the models we're using? Right, so this is what AI could do, what blockchain could do for AI, which is we can provide that layer of verifiability. And the other thing is back to the Sora video, which is if I'm a founder who are trying to make a video generation model, when I look at the Sora video, I'm like, holy crap, I'm screwed, right? Because imagine what my investors would be thinking. They would be thinking like, oh, this company would never beat Sora, right? So why would I even invest in them, right? So if I'm trying to close a round, then that will really suck for me. So a lot of companies have actually gone another route, which is open sourcing their model, right? So if you open source it, you get more contributions from the community. But at the same time, there's a concern about having no revenue. And also, there's also another type of resource where we would potentially want to monetize on, which is the content that is generated from these AI models. Right, so right now, it's pretty much just everywhere. If I use Stable Diffusion to generate an image, I would just post it online, and perhaps maybe could sell it or put it on like one of those like image stock website for people to download. Right, but how do I actually have an end-to-end process to prove that, hey, this image is generated by me. I'm the author of this image. I'm the one who crafted this amazing prompt to go into this model to generate this image. And hence, I'm the sole sort of creator or the owner of this copyright. So in this sense, we actually need blockchain to do some sort of tokenization along with verifiability so that we can have an end-to-end process of sort of monetizing these products of AI, be it models or content. So a very good example of how blockchain has helped AI development is actually a subnet under BitTensor network. So subnet 6 is actually created by News Research, which is a Web2 company that has moved into a Web3 space. And this subnet actually concerns about training model that will match GPT-4 performance. Right, so they take data from GPT-4, which is generated by another subnet, and then they are gonna ask their contributors to contribute models to try to match those responses by GPT-4 using some of other base models. So using open source based models. So essentially what they have created is this economy where everyone is really trying hard to train a model that matches GPT-4 so that eventually, and hopefully, we will have an open source GPT-4. So we talk a little about tokenization, and what does it mean by tokenizing a model? And what does it mean by owning a model? So hence, this is where some of our innovation comes in. So an ERC that is in draft right now that we wrote is called an intrinsic rev share token. So essentially, everyone who holds the token is sort of like a shareholder of whatever property, the underlying property that they are holding, or the underlying assets. So the model itself is not AI specific. It just have a revenue sharing mechanism as well as a burning mechanism, very much like how you will receive like dividends from like the stock market if you hold a stock. But what you can take this sort of rev share idea into is to actually help contribute or help define what does it mean by ownership of a model. So for example, essentially you can, well, one example is you could potentially use this token to fundraise, right? With the promise that future revenue will actually flow back into these token holders. So that's one way. Or you can also use these tokens as a way to incentivize your contributor, your open source contributor, right? So you can retroactively, or even in the future, actually reward your contributors with these tokens, such that if there's any revenue generated from these tokens, from these models, it will actually flow back to the contributors. Right, so then the last pending question of this is, what revenue, right? I've been talking about revenue, but there isn't really revenue that we have mentioned. So what does it mean by revenue, right? So we can have model ownership, but really you need to have some sort of asset that is generating the revenue. So one type of asset could be a AI GC NFT collection, for example. So this is just an example. So the corresponding kind of ERC that goes with it is 7007. So it's a standard for how to define like verifiable AI generated content NFT. Right? So if you have this verifiability that it comes from certain model, then essentially all the revenue that comes from this NFT collection, be it the royalty or the minting fee, could potentially be a revenue stream of that model. Right? And other revenue stream could be something, for example, like using our AI on-chain AI Oracle for certain models, right? People pay a fee for it, right? That is also potentially what would be defined as a revenue of that model. And that would flow back into kind of the model owners, which is the token holders, right? So combining everything, basically we call this initial model offering, right, taken from ICO, initial coin offering. So instead of selling just tokens, now you have an underlying asset, which is the model identity itself, right? And you can use this mechanism to define model ownerships and potentially have different incentives mechanism that can drive this model moving forward. Right, so at Aura, we have done quite a lot of different products in order to go to, that all comes together as this IMO initiative. So earlier I mentioned that we have had 2 research that concerns OPML as well as the intersection of OPML and CKML. And then we have an on-chain AI oracle where the security is guaranteed by OPML and everyone can make use of that result on-chain. And that oracle could potentially be one of the ways that models can make money, even open source models can make money by people who have the need to consume this AI inference result on-chain, right? And that provides the path to IMO, initial model offering, which is how potentially you can define AI model ownership and also have a revenue sharing mechanism for all the holders. Right, so that marks the end of my presentation. If anyone is interested to have the slides or check out the actual research paper, that's my link tree. And I don't know if we have time for questions. We do. Yep.
Does anyone have any questions? Oh, we've got one over here.
Thanks for the presentation, Kathy. So for the model ownership aspect, is there any kind of governance mechanism baked into this as well? Just kind of imagining how in AI, I mean, just assuming that they are able to be as powerful as the models that we have today, there's going to be a lot of concern over, their training and fine-tuning and kind of all of the, all those sorts of aspects of the models. So any sort of governance involved.
Right, so at this stage, so from this standard, it doesn't really specify a lot of the tokenomics and also governance. Really, it's up to the entity that is offering the tokens, for example, the AI company, to suggest whether they want such a sort of governance structure. But I can see that it totally can be used for example, even just to decide whether we want to update a model, right? Whether we want to update it into another version. But yes, but as far as the standard concern, it doesn't really specify all those. So the project still has the flexibility to pretty much define all these utility and tokenomics.
Thank you for the question. Was there another one?
You mentioned that the revenue will be generated from the people who want to use those AI models on-chain, right? But for the companies who are open sourcing their models, if they are open sourced, people can just grab it and use it off-chain, right? So how to guarantee the revenue for those companies?
Right, so that's actually a very good question. So I guess that's concerned the first part of the Winnie the Pooh meme, which is what does AI do for blockchain? So at Aura, we do have some ideas, but we are also really hoping for sort of the ecosystem to think about it. One of the ideas that we have is, of course, in the more of the DeFi side, right? For example, what does an AI model could potentially do on the AI front? A very simple idea would be maybe to replace the market making curve, right, with a model. Or maybe for a DAO to use this model to control their investment other than having a centralized treasury to do so, right? For DAO, you might not need a very high investment return, so a model might suffice. Other ways is AI-generated content, as I mentioned, right? So to have a provable creatorship or authorship that you want to prove. As well as I also have some ideas that I'm going to build over this weekend's hackathon, so I'm not going to disclose yet.
Any other questions? All right, if not, we'll start prepping for the next talk at 2 p.m. So make sure to come back for Perpetual Protocol. Give it up for Kathy. 1 minute. Please start taking your seats. Hi, everybody. Welcome back. We're very excited to present the next speaker, Xiao Gang from Perpetual Protocol. Please give him a warm welcome.
Check, check. Hey, I'm Xiao from Perpetual Protocol. Perpetual Protocol is a decentralized perpetual exchange since 2020. First, I'm going to introduce what is Perpetual Future. You may not, I guess not all of you know. So in a high level, Perpetual Future is a type of derivative contract that allows user to speculate the future price of an asset without expiration date. But why does this matter? If you look at Binance trading volume, perpetual volume is consistently higher than the spot trading volume. However, this does not extend to decentralized exchange. Let's take a look at what the current status and a brief history. So it's around mid-2020, the first generation perp DEX came out. And then there are more and more perp DEX every year. And around end of 2022, FTX collapsed. At that time, there are many crypto enthusiasts say, it's finally the time for decentralized FTX. It's probably true for spot trading, but it's not true for perpetual futures. As you can see, decentralized perpetual futures market share is just so small compared to centralized exchange. It's almost neglectable after everyone's hard work after the past few years. But why? It's common to criticize infrastructure. It's so hard to use MetaMask. Yes, it's expensive, the gas price is high, and it's also, waiting for a trade for a second, it's just super slow. But after some, thanks to the effort from the collective ecosystem, I think we are already reaching to a point that we can offer a seamless experience that users don't need to notice their blockchain underlying. But so will users transfer their fund from centralized exchange to decentralized exchange if it's fast, affordable, and easy to use? Probably not, unless there are some incentive or airdrop. But let's take a step back. How about decentralized spot trading? How about Uniswap? They all have the same weakness. It's expensive, it's slow, and it even has more phishing scam because after, me too. But look, Uniswap overpassed Coinbase last year. So how does decentralized spot trading thrive when they have all the same weakness? Is there something incredibly valuable for a user that so they can overcome these hassles and even the centralized exchange is easier, faster, and cheaper, but there's just something that centralized exchange cannot compete. As a decentralized exchange, should we focus on improving the weakness or strengthen our strength? I think improving the weakness is undoubtedly important, but most of the time, a user uses a product. It's not because it has less flows, but it has something that is extremely good in some unique use case that no one else can offer. Think for on-chain trading, democratized liquidity provision is the key. And that's the strength of DEX. So can we just apply this lesson from spot DEX to perp DEX? We have some experience over the past few years, but the answer is not that straightforward. Let's take a look at the liquidity mechanism landscape. So first, peer-to-pool model. It's very easy to understand for retails, but it's also quite vulnerable due to its static nature when market conditions shift. And next, peer-to-peer, and of course, limit order. It's also very flexible, but it's just so hard to make it on-chain. Some of the interesting approach like WARP, W-A-R-P, they have something that worth exploring. But it's still very hard and expensive to build active market making strategy on top of that. And also, range order, invented by Uniswap. We used to think that's the closest answer. So that's why we built the Perp v2 on top of Uniswap v3. But it's still very expensive and hard to build an active market making strategy and build a maker vote for retails. We do have some hard lesson from running Perp v2 for 2 years. But from those lessons, we came out with a very simple idea that can fix those issues and just, we call this smart liquidity framework. It's Perp v3. It's a generic platform for any liquidity strategy, as long as they can generate a price. So we're coming from the bounding curve and range order. Then we move a further step. We abstract the LP strategy away. We call this LP abstraction. So what does it looks like in practice? For example, anyone can build a strategy on top of a very simple constant product formula XYK, and then just use this as a price. But most of the LP may not want to use this. Of course, you can also utilize an external oracle. Could be Chainlink, Peace, or even your own private oracle. So it's just very simple, just use that price to market make accordingly. But what's more than the pricing, the programmable pricing, is you can run arbitrary code on your maker, your strategy. So by decouple this pricing engine from the trading strategy, there are so much more things we can do. For example, at the sample code shows you can put your idle fund in some lending asset like Aave and earn yield. And you can also, when there is some take a trade with your maker, you can just hedge in another venue. And if we, this example is very powerful that it's something similar to like a basis trading strategy. So let's take a look at the basis trading strategy example. So this maker, I mean, the trader Alice want to take a 1 ETH loan, and this maker running a basis trading strategy, you can just concurrently buy 1 ETH at Uniswap to get 1 ETH spot, underlying spot to hedge, and maybe you can optionally add a spread on top of that price. But essentially, this trader get the same price as Uniswap with leverage. So it's something like it can utilize the liquidity from Uniswap with very low capital. And for LP, it's also a very low risk strategy that, since it's a delta neutral strategy. And it's not only limited by trading between spot and perp. You can actually integrate with every other DEX or even centralized exchange. It's basically bridging all the liquidity from other exchange into the same place. It's probably not new for professional market maker, but it's revolutionary for retail. And since you can have so many strategies, so what does a workflow looks like? So to provide a better user experience, there will be something like a router on top of all the strategies. And then this UI trader can just use that router to route to the best price among all the strategies. And for bot or smart contract, you can also, of course, bypass this router to integrate with each strategy directly. And what's more interesting thing is the position across different strategies are fungible, which means a trader open a position on strategy A, you can easily close your position on any other strategies. This is not only improving the price, because every strategy has its own strength and weakness. But it only creates a new dynamic between strategies, because a strategy can rebalance their exposure between other strategies. So let me summarize what I've shared about the Perp v3. So it appears to pools model, so trader can benefit from infinity strategies. And by having this programmable pricing and hook, anyone can build different kinds of strategies. It could be AMM, Oracle-based, could be on-chain, even off-chain strategy, can hedge or unhedge. So it makes us or other like market maker, risk expert, a lot more flexibility to build different kind of strategy. And we can even utilize this framework to build a retail-friendly LP vote to welcome the broader audience. So imagine a year or two, when someone represents this market dynamic between decentralized exchange and centralized exchange, I hope the chart will be different. And we're going to open source the Perp v3. It's not business license like others, so welcome to take a look and risk at your own risks. I believe that everyone should have a better and transparent trading experience. Thank you.
Thank you. We have some time for questions oh, great. If anyone has any questions. No? If not, you know where to find. For the next talk, we have Baseline coming up. It will be at, what time is it now? 2? It's 2 now, but it will be at 2. It will be at 2:30. So come back for Baseline, and if you want to take a quick break, and we'll be back soon. Today we have Indigo and Fully from Baseline. It is a new DeFi protocol on Blast, experimenting with interesting tokenomics. Please give a warm welcome to Baseline.
Test, test. Hey,
Test.
hey, hey. Hey, okay, it works, it works. We're good, we're good. Hello, everybody. Thank you, Cindy, for the introduction. Thanks for coming. My name is Fully.
I'm Indigo.
And we're here to talk about Baseline protocol today. Okay, so Baseline protocol is a new kind of like market-making system that we've tried to design to democratize liquidity and trading on-chain. The main premise behind it is that instead of having to work with third-party market makers or service providers when dealing with your token listing and trading, we wanted to create a protocol that allows anyone to deploy a new ERC-20 with liquidity and tokenomics kind of built in from scratch. Okay, so what does that mean? Baseline is a market maker, but not everyone, is very familiar with what market makers do. So market makers basically are market participants that trade assets, buy and sell assets, and make trading easier for different market participants. What they do is if you need to sell or you need to buy a token, there's always someone on the other side that's willing to make the trade with you for a good price. So if you don't have a market maker for your token, you don't have liquidity, anytime someone spends a small amount of money buying the token, or if they sell a small amount of the token, you see the charts kind of go crazy. And that's because there's nobody in the middle servicing the trade. So what we're trying to do is we're trying to find a more decentralized and permissionless way to facilitate that for everybody. Okay, so why do we decide to do this? Market making is actually a very complicated and difficult issue that we have to deal with in crypto today. Right now, I think the biggest problem is with the traditional model, there's a lot of incentive misalignment and a lot of problems that come with this. So going back, yeah. So the first thing is that market makers, when you work with a market maker as a token project, the incentives of the partners that you're working with aren't necessarily aligned with the incentive of the token holders and the team. In order to make money as a market maker, you have to be extractive in the market. Basically, you have to be profitable trading. If you're not profitable trading as a market maker, you're going out of business. But if you are profitable trading as a market maker, then you're taking money out of the markets from other holders or people, and you see, the value of the tokens slowly going down, and liquidity, net liquidity that comes in and out, slowly move out of the market. The second thing about working with a market maker as a firm or a company is that you have to trust that they're going to do what they say they do. So if you're a protocol founder, you want to launch a token, you work out a deal with one of these firms, you have to hope that they are going to buy the token and sell the token under the predefined terms. And for a lot of people who've worked with market makers before, that's not always the case. They don't necessarily provide liquidity when they say they will, and it causes a lot of problems. And so the third piece is that in order for these liquidity deals to happen under the traditional model of token economics, you have to give your market makers a large percentage of your initial supply. So, if you mint all the tokens, maybe you give 10% of all the tokens to the market makers. They go to an exchange, they start selling your tokens immediately. And the problem with this is that one entity basically has control over all your tokens. They decide when they want to sell it, when they don't want to sell it. They decide when they come, and buy it back, and it gives them a very big advantage for everyone who's trying to trade your token. So at the end of the day, you have this very imbalanced market where the guy who owns, all of the supply is actually incentivized to extract as much value as they can, providing liquidity in your market because, they have to pay for their offices, for their salaries, they have to grow their company. And so, all of this ends up with what we have today, which are, a lot of tokens with a lot of really bad deals, and listings are very expensive, and things end up kind of trending down only over time as liquidity is kind of leaving the markets. Yeah.
So that brings us next to automated market makers. So as we do in crypto, we generally replace old financial institutions with things that can be automated and are permissionless. So in our case, for market makers, we've created things called automated market makers. And you know these popular protocols like Uniswap. So what these are very simple market makers that make it permissionless and open for anyone to be able to be market makers for tokens. They can provide liquidity as they please. There's other systems that we've identified that we call automated liquidity systems that are smart contracts built on top of automated market makers. These are less known, but they're designed to replace the need for traditional market makers in that they can buy and sell tokens for certain protocols or teams. What's nice about these automated liquidity systems is they don't really have the incentive alignment problem, as they're just programmed to do as they are, they're just programmed to make fees as they do, and they're built to the benefit of the token holders generally. They don't have a need to make money, pay salaries, anything like that. They're also guaranteed to perform the way they're programmed to be. You don't have to worry that they're gonna dump on you or whatever, which sometimes is the case. So some useful properties of these automated liquidity systems are that they're deterministic and that you know exactly what they're gonna do. They're non-extractive, so they don't have to make money for themselves. They can use any fees and revenues that they generate for the benefit of token holders or the protocol itself. They're also transparent and auditable, so you're not really worried. You can always check on chain what the code is doing. And they're designed to act as the primary market makers for the tokens to replace the traditional market makers. And last, I think this is a really important point actually, is they act as guarantees for market participants. So since everybody knows the rules of the market, they're able to, you as a trader, as a holder, or as a liquidity provider yourself, you're able to design your strategies around that, which is, I think, very, very important. And I think many people don't really think about this until you kind of see these systems in action. So some examples that are out there are my personal favorite, Olympus Range-Bound Stability, or RBS. RBS is designed to buy and sell and market make the OHM token fully on chain. And what it does is it keeps the price of OHM within a certain range. But it still allows the market to break through this range if there's enough buy or sell pressure. So what it kind of does is just supports the market and what it's trying to do rather than keep it at a peg or anything like that. Another good example that many people don't really know about is White Lotus, which has been a big inspiration for us. So White Lotus was a small project in 2023, like in the trough of the bear market. White Lotus was a system built on top of a concentrated liquidity pool, which what it did, it concentrated all of the reserves in the pool, so all the ETH into one certain price. So it was designed to be able to absorb the entire circulating supply as a floor price. So if everybody dumped their token all at once, they would be guaranteed this floor price, no matter what. And you'll see, this was like a huge inspiration for us at Baseline. And last, something a little bit different is the Frax AMOs, or algorithmic market operations. These things many people don't really know about, but this is how Frax maintains their peg at $1. Frax is a stablecoin, by the way. So Frax, what it does, it allows these smart contracts to mint and burn Frax into their liquidity pool to maintain the price at $1 at all times. There's also a lot of other systems like this. I don't think it's been talked about a lot in crypto, but that would be like a whole nother presentation on its own, maybe for later.
Yeah. Okay, so that leads us to Baseline. So as Indigo is saying, automated liquidity systems basically replace market makers with smart contracts that do the buying and selling as your token counterparty for you. And so at Baseline, we kind of took the inspirations from a lot of the other designs that we've seen and we've consolidated it into one simplified system that is built around a Uniswap v3 concentrated liquidity pool. So what that means is we're trying to do all of the things that we've seen from the previous systems, from White Lotus, from Olympus RBS, from Frax AMOs, and we do that all in these concentrated liquidity positions directly on chain that you can see. And we'll go into a couple of those mechanics in a little bit. Yeah. Okay, so the three main components of baseline that I think are important to understand. One is called the baseline value. The first one is baseline value. The baseline value is the minimum price at which any baseline token can be sold forever. And this is always guaranteed. The liquidity to buy back that token will exist in the Uniswap pool. It's immutable and you can't touch it. So no one can take it out or move it. We can't do anything with it, even as like the team or the devs. So it's there forever. And it's enforced through the market making system. And so what the market making system does is it takes a concentrated position in Uniswap and it looks at, okay, can this position, if every single token in circulation today was sold at the same time, can this position still buy back all of those tokens and have a little bit of ETH left over? And we do calculations in the smart contract to move this position around so that this is always the case. So no matter what, if everyone sells everything tomorrow, the baseline value is the price that the last token will be sold at. The first token will probably be sold at the market price, and then as the price goes down and down and down and down, you'll see the minimum price is the baseline value, and that's where it's at.
One more thing. The baseline value is also designed to only go up. So whatever the price is at initially is that we actually calculate it on chain such that all the fees and everything that we generate make this baseline value to either stay the same or increase over time. It will never go down.
Do you want to talk about the credit facility?
Sure. So the credit facility is designed, since every token has a BLV behind it, such that commonly it's just a value of ETH that every token is backed by, you normally wouldn't want to sell your token to be able to access that floor price, that BLV. So what we allow you to do is actually borrow this BLV at any time. And what we do is we actually allow you to do it in a non-liquidatable fixed rate and fixed term loan. So you can take this at any time and
with no oracle.
With no oracles, by the way. There's
Oracle-less, non-liquidatable lending.
Yes, it's pretty cool. You can take this amount, or you can take this BLV at any time. And what's nice about is that normally when you hold a token, you usually have to you're either thinking of buying or selling, and sometimes you can stake it or do something like that. This gives a native utility to the token as an alternative. And I'll show you later the effect of this on the price charts. It's very interesting. But what a lot of people do is they'll buy the token and then they collateralize it and borrow the BLV, and they often loop it back in. So they take the BLV and they buy back the token to get leveraged exposure to the price increases. But they can also take the BLV and stake it into a lending protocol, or you can provide liquidity on a separate market. You could do whatever you want with it. So it just gives a lot of native utility to the token.
Yeah, so I just want to add a little detail here. So one of the reasons why the lending can be non-liquidatable and oracle-less is because the protocol basically has the guarantee of the BLV. So when you're taking the minimum value of it, where the money is actually coming from for your loan is coming from the Uniswap pool directly. So the protocol normally has this ETH sitting in the pool that's reserved to buy back your token at that price. As soon as you collateralize it with the protocol, it realizes that it doesn't need that ETH to sit there because it now owns the token that you would have to sell. Because the protocol has the token, it can give you the ETH ahead of time by pulling it directly from the Uniswap pool and letting you use it for whatever you want. So as Indigo was saying, a lot of people are trying this mechanism in different ways. Some people just go gig along on baseline tokens by borrowing the ETH of the pool, and then they put it back in. And people have called this looping. So you just kind of borrow, buy, borrow, buy, borrow, buy, borrow, buy. And it depends on the difference of the current price to the price that you're getting the loan, how many times you can do this efficiently. But it's really cool to see that at launch from day one, when we made a token, people are able to borrow and leverage directly inside the Uniswap pool. You don't need a perp integration, you don't need anything, and you already get a lot of exposure.
It's also guaranteed to be solvent because there's no liquidations. We just default the loans if they don't pay back, and everything actually just stays solvent in the end.
Yeah.
And lastly, all the interest and everything that gets paid to this credit facility goes to increasing the BLV for everybody.
Cool. Okay. Yeah. I mean, okay. So both of these mechanics work in different ways to accrue value to the baseline value. And I guess the reason why we even kind of went down this path is because Indigo and I are both notoriously not great traders. We really like to believe in the projects that we invest in and buy. And the way crypto works today, in my mind, is it really incentivizes and rewards impatience and profit taking, because the structure of your crypto tokens, the markets are very thin in terms of liquidity. So the first people that capture it actually take all the upside. But that's not very good in my mind if we have a community of people who want to believe in the things that they're buying and holding. And so the mechanic to kind of reward that is to take the surpluses and fees that are happening in these pools and moving them into a minimum value, so that people who are holders, people who are patient, people who don't want to just trade their token for quick profits, they have other alternatives and value accrual mechanisms built directly into the tokenomics, so you're not kind of trying to fight and figure out where your entries are and where your exits are and time everything perfectly. So this is one way that we've tried to find how to give more advantages to passive holding and patience, as opposed to just active trading, and balance out the dynamics a little bit there. Yeah. Sure. Okay. So baseline protocol. So we're kind of associated with two things. One is the protocol, which is called Baseline, but we launched a token on this protocol called Yes. So Yes Money 420 is the Twitter handle. There's been a lot of hype around it on Blast, actually. So we launched on March 3rd, and this is the first of many tokens that we plan on launching on Baseline. We think that there's no perfect or optimal liquidity structure or market making strategy. Different tokens will want different structures. Yes is the first of many to come. It's right now the most liquid pair on Blast. Something really cool is we did $300 million of volume in the first 48 hours of launch. We've reached over $500 million of volume on Blast. We're over 30% of all total volume traded on the L2 right now. So it's been a pretty crazy ride. Yeah.
All right, I would normally not put a price chart on a technical presentation, but it's pretty interesting, relevant. So I just wanted to show you guys. So we didn't, as we designed the system, we worked on it for almost a year, and we tried to explain to people, but nobody really believed that what we were saying was possible, or that it was, or they didn't really think it was significant at all. So rather than try to keep explaining to people, we'd rather just launch a token, make a cool meme or a funny meme, and then just let's just show people what it can do, right? So this is why I show it up here. So you can see the green price right here. Let me move my laptop. You can see the green line right here. This is actually the BLV. And I know everyone, when I said BLV only stays or goes up, no one believed me, but this is actually what it's doing. So some interesting things, as you can see. One interesting thing is that because we have this alternative to buying and selling, you can borrow and do something else with it. There's actually a lot, you can't really use technical analysis or something on this chart. It just looks so weird. And I don't think I've ever seen anything like it before. So you can see at the front, holders would rather actually borrow than sell, and this is why we get these humongous green movements up here, because everyone's just very degenerate, especially if you don't liquidate their loans. So that's what's happening right here. And then what's interesting is that people, as they loop, as they borrow and then rebuy the token, you're actually getting multiples of exposure on your BLV increase. So if you loop however many times and you get like 3x exposure, the BLV increase is 2%, you're actually gonna get 6% on your BLV increase.
Hold on, let me jump in real quick. For context, one of the coolest things actually about the lending system is, so we're lending always what the green line is. Against one yes token. When that green line goes up, you can actually borrow more ETH for no extra collateral. So when we launched, someone put in a couple yes tokens, and then they waited maybe an hour or two later, and they asked me, hey Fully, is there a bug? I'm pulling ETH out of the system, but I didn't buy more yes. And the answer is no, there's no bug. Actually, the system is working as intended. What's happening is that your guaranteed value of the token is increasing, and the system is able to provision more ETH for your borrow. So the dynamic that Indigo is talking about is for all of the people that actually looped, they borrowed and bought and borrowed and bought, and they're like 4 or 5 times levered. When the floor price is going up, they're actually borrowing 4 or 5 times the floor price value against the original money they put in. And this is kind of like a very crazy dynamic that we haven't really seen before. And the other thing that's really funny is now every time when the floor goes up, you see a lot of bids come in as capital gets unlocked in the system and the risk is being repriced.
You can see it, like every time the BLV increases, there's like humongous green candles.
That little yeah.
Yeah, and so it's really interesting to see. The other thing is, yeah, I got a lot of bug reports about that. People are like, oh, your lending system broke, it's giving me free money. And it's like, no, that's just how the system works. Okay, so another really interesting thing is like because how much of the supply is actually collateralized, even though the BLV is like a hard floor on the price, there's kind of like this effective floor. And the guys at Ajna actually told us this, that they were intending to actually lend at a price higher than our BLV. So it's kind of, it's just a cool property of the system. And then lastly, what I think is really interesting is, so anyone who looped, where they like leveraged and bought, under the current BLV, they have very little incentive to sell. What they do is like they usually just sit on their loan and they just, every time the shift happens, like they just get their increases in the BLV and they're just happy sitting in the loan.
Yeah, so I think like one of the most interesting dynamics about this is in a baseline type market, the risk and reward is much more transparent to traders. If you're buying a token, so first things to consider, one is we don't have any external supply from the beginning. So there's no tokens that go to the team, there's no tokens that go to advisors or investors. Everything that's ever bought is basically bought from the pool, and the money that's used to buy the token goes inside. And the second thing is, because you have this like much more fair supply dynamic, and you have like a risk that's defined, you can choose what your risk trade-off is. You don't have to guess, oh, is it going to fall to this price or that price? So unlike most tokens, you have a reverse incentive to sell as the price goes down. Because when the price is going down, the risk, the amount that you have left to lose continues to go down. So now you have a trade-off. If you don't want to stay in the asset, you can still exit at very, very deep liquidity. But if you believe in it, you also have opportunities to double down. And because of that, and because of the leverage that comes from the credit facility, what Indigo is saying is the prices will get closer and closer to the premium. That gives more people leverage and more incentive to buy it. And so, yeah, you have counter-cyclical incentives that are at play.
One last thing, I only talked about like people buying. I also don't want to make people sell this thing too, actually. And so you can see up here, there's like the giant red candles. These are leverage unwinds. So people are just like repaying, then selling and repaying and selling. But what's happening, it just keeps getting eaten up because there's actually more, was it 20x? There's more ability for people to buy than there is actually circulating supply to sell. So you see like there's like huge levered unwinds, but like it just gets eaten up right away. And but I'm not saying like there's no risk in the system. The risk is actually in the premiums up here, right? But it's just interesting that like we're still like discovering how these market dynamics work.
Yeah, it's a completely new market. One thing that we find that's like actually really interesting is, so if you think about the efficiency of your loan, it's the difference between the market price and the floor price. So if you have if the price is $5 but the floor price is $4, you're getting 80% of your loan back. Every time you loop that, you're getting 80%, 80%, 80%. So in an infinite series, it comes out to some like it converges towards some like X leverage, right? When you loop at lower premiums, the LTV goes up and the available leverage in the system increases. So it gets harder and harder to push the price down towards the floor because the compression of the premium brings up capital efficiency in the system. So the system is almost like a shock absorber of liquidity, where it kind of like loads up a spring and then, as it bounces up, it kind of like unwinds a little bit. And if you're trading or you're thinking about, trading these types of assets, the thing you consider isn't like, okay, what is the price and what do we think the price is going to be and what's the FDV? All you have to really think about is like, okay, what's the minimum price? How much capital efficiency do I get from participating in the system? And, what is the kind of like risk premium that I think, is too high and that I should be selling at? Yeah.
That's it.
That's it.
Oh, we have some cool graphics.
Yeah. Yeah. Shout out to our like really awesome designer, Pillhead, who like makes these amazing pieces of art. Yeah.
Yeah. So I just want to say like what we're building next. So currently we launched Yes. There's a lot of learnings with that, and so we're currently working next on the Launchpad, so that anyone can be able to create their own baseline tokens as they want. That's currently going to be in audit soon, and it'll be out soon, hopefully. And here's our socials if you guys want to follow along.
Thank you. We do have maybe 2 minutes for questions if anyone has anything they want to ask baseline. We've got 2 questions, so we'll do that one first and then we'll have you ask yours.
Can you hear me?
Yeah, that's better.
Yeah, it was really great presentation. Thank you so much. I've known your project actually. Yesterday we talked about it, but actually I didn't realize that this is that project. Your project was kind of very viral in Blast in the beginning.
Yeah.
As a concept of ERC 4220, right?
Yeah.
Can you explain a little bit about the relations? What is the ERC 420?
Sure. Yeah. Okay. So, just to clarify, ERC 420 is a joke. It's mostly just a meme. It was for marketing because we saw like ERC 404 and people were talking, what was a real standard for us. So 420 just alludes to the fact that the price just keeps getting higher. But it's a meme. It's a meme. The price, well, there's fluctuations obviously based on the baseline value. But what we're trying to highlight, actually, the reason why we alluded to that, well, 2 things. One is we wanted to, we wanted to make sure people weren't, taking this too seriously. It is an experiment after all. It's the first of many, and it's the first time that we've ever seen any token like this. So, we know there's going to be potential issues or things like that. So we don't want to say, hey, this is like official coin. It's a meme coin. It's like 420 ERC. The second thing is the standard. And I think it's really important for us that, the reason we build this isn't just because we want to launch tokens, but because we want all tokens to be like this. If you have Yes in your portfolio, no matter what the price is doing, you always have the liquidity available to do other things you want in it. So if you don't want to loop, another strategy is that you can hold it in your wallet and you can borrow the ETH against it and you can LP it for yield or farm or do other things. And to me, if you have a portfolio of assets like that, where you know exactly what your guaranteed floor is for all of your holdings, and you have extreme capital efficiency, I think that is a kind of standard that we should be moving towards. And the other thing about these tokens is because they're all managed by the smart contracts, they're not ruggable. Devs can't just mint themselves new tokens and dump in the market. So they're much more secure. They're much more, protective of the capital, and they're much more rewarding for long-term participants. Yeah.
Thank you. Thank you.
All right, thank you very much. I think we'll move on to the next panel. Thank you, Baseline. Give it another round of applause.
Thank you, guys.
Sorry about that.
I do have a question about 烟味，30分钟还是1小时？40分钟。
Thank you, ClickClack, for the Wi-Fi. Okay. Are you guys ready? And now for the DeFi panel. Everyone, please welcome. Yes, do you want to go first? Everyone, please welcome June from Sora Ventures. Oh, we're somewhere. Okay, well, he'll be back in a second. Oh.
Check.
All right, well, everyone now welcome June from Sora Ventures, Tom from Zoma, Jerry from Terram Structure, Yenwen from Perpetual Protocol, Rand from Orderly Network, and Lennox from OKX.
Hello, everyone. So I'm happy to have all of our panelists join this panel. Yeah. So let's give a brief introduction for our audiences of what you're doing and who you are. So let's get started from myself. So this is Jun. Sorry, I was just running back. It's a little bit. So this is Jun. I'm the vice president and technical partner of Sora Ventures. But I prefer to call myself as a DeFi native since my first project is also in DeFi. And then I really like new things, and I'm friends with all of the panelists for many years. So let's move on to Tom.
Yes, I'm Tom Song from Zoma Protocol. Yeah, actually I joined the crypto world maybe more than 10 years. Yeah, maybe people in Taiwan may know me. And we are doing a DeFi protocol, and it's about the option. The name is Zoma Protocol. And before that, we had another project. It's a DEX called Joiso. Thank you.
Hi, my name is Jerry Lee. I am the youngest here. I'm in this space for only 2 years. So I used to work in the bank for over 20 years. I was doing my whole career life is trading fixed income and currencies in the bank. And just 2 years ago, I just figured out like a DeFi is so attractive, it's so amazing. So I decided to retire and resign and jump into DeFi space, and I built a term structure. The reason why I'm doing this is because I do fixed income for my life, and I find there's no such thing in DeFi. So this is something that I wanted to build up.
Hi, I'm Yan Wen. So I'm the co-founder of Perpetual Protocol. So we do perpetual swap on chain on Optimism. And yeah, I think that's pretty much about it.
I'm Ran, co-founder of Orderly Network. We're a shared order book liquidity across different blockchains. Currently, volume is about 200 to 700 million a day on the perpetuals. And we cater to all types of DeFi builders out there. So if you want to plug into our liquidity, please feel free to ping me.
Yeah. Hi, I'm Lennox. I'm the CCO of OKX. We are one of the biggest exchanges, central exchanges, but we also build our Web3 wallet, and we also have our ZK roll-up perps and DEX to be launched in Australia.
Cool. So it's our pleasure to welcome so many OGs in the space to share their opinion with us. So let's dive into the panel since we don't have that much time. So first, I would like to ask everyone, like, can you share a little bit more about what's the current barriers and difficulties of working or building on-chain derivatives nowadays, since most of the attentions are around like meme coins or like NFT things. Like for more advanced on-chain derivatives, it's usually more difficult to build. So yeah, I think we can start from Yan Wen.
Yeah, I think that, okay, so let me put it this way. So on-chain derivative is hard now. I think mostly because of performance of blockchain. It's not there yet. Most of the blockchain we use are Ethereum based, like Layer 1, Layer 2. Scale, like, TPS is like 10 transactions per second, around there. So I mean, like a lot of, I guess if you compare to like Binance, I think they can handle maybe like 1,000 TPS right now. So that's a gap. For spot market, I think that's probably fine because like the baseline guys said that the whole like AAM movement actually we can bring liquidity to the retail, like on the smart market. People can mint their own token, project can bring their own token. But on derivative, it's much harder because because you have leverage, you want to trade at the fastest you can do. So I do think that performance definitely is the main blocker for the derivative.
Got it. Like speaking of performance, I think like Jerry or Tom could also chime in because like if I recall correctly, term structure is built in on like customized L2, right? To basically have cheaper gas. And for Zoma, it's also on ZK Sync, right? So Jerry, would you want to share some like barriers or difficulties that when you're building like term structure?
Yes, thanks. So I think clearly I agree with what Yan Wen said. I think just the short answer is the TPS constraint, right? Whatever we do on chain, I think this is something that we need to solve. But the term structure we want to solve the problem is on when we talk about derivatives. Derivatives basically derived from some other financial instruments, right? So what are the basic financial instruments? We don't have fixed income. That's why I wanted to come here to do this. And the way we do is that we build, because fixed income is actually allowed users to put their asset for a longer period of time. So I think the security is important, scalability is important. So that's why we build our own DK rollup. And based on this layer 2, and we trying to create a yield curve for ETH, for BTC, for like major stable coins. So I think the thing is that without yield curve, the derivatives will limited to what we have today, like perpetuals. We may trade like 10 times of the volumes than today's on perpetual protocols like products, or like Zoma's like option products, or the swaps, right? But we're still limited to like the use case we have today, right? So we wanted to create a new use case I think that is the most important things we want is like, just like we go into the bank, we see like 100 different products. But here in DeFi, we don't have that many. And this is because we don't have the yield curve. That's why I think this is important. To me, this is the obstacles and on-chain DeFi.
Got it.
I totally agree Yanwen's point of view, and but because for myself, and actually I trade almost maybe millions of dollars on stacks every day for the perpetual future and the options, and in my experience, the user experience is not good as stacks now for on-chain derivatives. Because actually, if I use on-chain derivatives, maybe I will use my core wallet to sign, and it's not a good experience actually, and it costs a lot of time, and actually the user experience is not good, and also there are other costs, maybe for the gas. And the convert time is very long, so it's not easy to use actually. And also it has another cost for the. It's not easy to deposit US money from our daily life to on-chain. It's also a big problem.
Got it. And besides performance, do Ren or Linux has other opinions since you guys are also, building things on chain like OKX also expand into on-chain things, or at least has already been building like shared liquidity order books on chain. Yeah.
Yeah, I think one of our key challenge currently is we want to make sure the mechanism of a centralized system mechanism is, I mean, the rules and the mechanism is on a centralized system is exactly the same as CKP proof system. Whenever there's some mismatch, so which means that even the orders being matched on centralized matching engine got rejected when we upload on chain. So yeah, aside from performance, this is something that we're still trying to figure out what's the best way to do.
That's really good. Yeah. How about Rain?
Yeah, so there's many real life, many obstacles, like from the onboarding part, which I think OKX Wallet and other gateways are trying to solve, to fragmented liquidity. That's one of the issues that we're solving, hence shared liquidity between the chains, to many like idiosyncratic issues with like outages of blockchains. Optimism, we have a vault there. They were down for a bit of time, and then outages with bridges, right? Like we're integrated with Layer 0. Layer 0 is sometimes there's blockages, and then like our users are cross-chain messaging between Layer 0 and our own chain, which settles all the trades. And sometimes there's blockages there, and then users can't withdraw assets. That's a big problem. And then when gas prices go up a lot, right, on different chains, then we have to. Users are withdrawing deposits, it's crossing messages with us, and then we have our own chain, so then all the prices go up, we might have to increase withdrawal fees, things like that. But with the latest upgrade, that's gone down quite a bit. So there's all types of issues that deals with performance, costs, and user experience. I think the user experience, like Tom said, it's not there, right? We're trying to make the experience on Orderly like that of Binance, where users are depositing from one chain, a native asset, withdraw from another chain, also the native asset, let's say native USDC, and they don't have to deal with wrapped tokens due to any sort of bridging risk, right? I think the eventual goal is to have a DEX that looks like OKX, right? And feels like OKX, but it's fully transparent, it's DeFi, and it has even the Web3 tokenomics that we love about DeFi. Yeah.
Yeah, thanks for sharing. Actually, I have some like secret alpha that I will share with you about like the infinite liquidity for cross-chain thing. But by the way, so thank you for sharing so many like different like practical and theoretical barriers and obstacles around building things. The follow-up question is, there are so many barriers. So what's the singularity point that you see to solve this issue? Like from your perspective, also from, it could be either from your perspective or your protocol's perspective or in general from the DeFi perspective. Yeah. Anyone want to start with this?
Actually, Roma has launched on ZK Sync, and you know, everybody knows ZK Sync is a new ZK L2, and it supports AA account and also paymaster. I think it's a big change. And in the traditional way, we have to prepare ETH for the gas. Every time you trade, you have to sign but in ZK Sync, you can now pay with any tokens you want. And I think it's a big progress. And also, AA account also supports not only the private key, the traditional private key. It also maybe you can use your Google account to generate a account on ZK Sync, and I think it's a big progress. The user experience improves a lot, and maybe it will be like the Web 2, and everybody used to use Web 2 finance. I think it's a big improve.
Got it. So, so from the user experience perspective, it has like some good progress, right? And then to basically approach the mass adoption. Okay, cool. So besides like user experience, and then like most of you are talked about like the performance barrier, like the difficulties, right? So after Duncan upgrade, do you see like there's some improvement right now? Or like in the near future, what do you see that could also help the performance things? Because like if there's like different L2s, even if they can improve the performance, there will probably be some like liquidity fragmentation issue as well. So yeah, anyone want to like chime in on this topic?
Yeah, I can chime in on the performance. I actually don't think that we will have centralized change or like a traditional finance performance anyway. I mean, like it's not about like you know, our technology not advanced enough. It's just if you want to be, you know, like decentralized, it's just hard. So I think like so currently I think people are trying different ways, like orderly, like hyperliquid, Avo. They want to build like really efficient off-chain order book and then populate the data on chain. That's one of the way. I think that's really efficient. Yeah. So and the other, I think like the other approach is like us, like Perpetual Protocol. We want to build everything on chain. So it will be like making market maker in, I mean like just a different design. Like we just try different designs of the making market maker. I think just, personally, I think that these two approaches will coexist for some time. Just like Uniswap and centralized change, they coexist because they have different needs. And yeah, but that's just, yeah, in short, I think performance cannot be achieved, and then people just need to get around it.
Yeah, a little bit like side notes, because yeah, I totally agree with that, because like AMM and order books will be coexist forever, because like there's, in my opinion, they're like serving different questions, like serving different problems. So there will always be different target audiences will use this type of like two types of things, because like when NMN was firstly introduced, it was supposed to solve the long tail asset issue for the liquidity. Because like usually in the traditional finance, if it's order book based, there's no stupid market makers want to like come in and actually take the counterparty risk of like tokens. Yeah. So yeah, agree with that. Probably like I'm also curious about like what's Rain's point of view on this, because like it's like share liquidity books that Order is currently building, but it's on chain, and then it has to solve the performance issue right now, right? It will definitely be like less efficient of like building a centralized order book. And I know like your teams also have the background of like traditional finance and then do like high frequency market making and also do like asset management. So what's your point of view like doing a share liquidity order books, or what's the point of that? And then how the performance issue affect your strategy or the roadmap of Orderly?
Yeah, I think we're trying to be as, like, it's all about users at the end of the day, right? So we have two types of users. One are the protocols building on top of us, whether the AMMs or centralized exchanges or whatever. And then it's their users. So then that experience has to be good, right, for them to even want to use it. And it's got to be good or as good or even better than centralized exchanges for that shift from CeFi to DeFi. And there's so many components that come from that. It's not even just about us, it's about the onboarding, it's the fiat on rails into DeFi. I mean, a lot of missing pieces. There's about KYC, or ZK KYC. So we're just solving for the liquidity and chain abstraction component of this equation. And we're trying to do it in as decentralized and robust as possible, right? But at the end of the day, if the performance sucks, the users are not going to use it, right? So we have to consider that first. So our solution currently is an off-chain order book, so kind of similar to DYDX v2. And then it settles on chain our own orderly chain via OP stack. So then all the balances and trades are printed by block onto the chain, which links via layer 0 to all the other chains that we have our custody vaults. So then if our centralized order book shuts down for any reason, then users can withdraw their assets if they want based on the data on the chain, right? So there's no asset risk. But eventually we do want to put the whole order book on chain. I mean, DYDX has a way of doing it, right? That seems to be working for them. So, I mean, there's different possibilities. And I think the technology is upgrading at a speed that will allow us to achieve this in the near future. I mean, I don't think it's going to be, it's going to take forever. It's going to take many years to do this, right? And so the point of singularity, I think, is still the experience has to be the same, if not better than centralized exchanges. And then DeFi has lower cost, right? Less people needed and utilizes the community. Versus like 4,000 person centralized exchange. So then there's a big cost advantage here, right? And then the tokenomics are such that everyone is rewarded, or I mean, that's the way it should be, is for their contributions, right? Whether they're a token holder, whether they're a trader or whatever. And that's also non-existent or barely existing in centralized exchanges. So I think it has all the elements there, the performance and the liquidity, and there's permissionless listings in DeFi, which I think is key, right? So once that's all in place, I don't see any reason why the volume would not shift towards DeFi and eventually even from TradFi, given all the custody solutions and the regulations and the KYC, all that stuff is in place, right? So I think that's kind of the point of singularity. I don't think it's going to take 10 years for that to happen. I think it might be 5 or even less. Yeah.
Cool. So Jerry also come from like, if I recall correctly, also come from TradFi from Dash Bank, right? So like from the traditional financial person perspective, yeah, what's the different? What's the singularity points for you? Because like you have like both the experience in CeFi and DeFi. Yeah.
All right. I think this from fixed income perspective, right? Because I think this is the big difference between these swaps or these the futures or perpetual futures or fixed income. It's just the big difference is like the fixed income in real life. We actually I think the most of the retailers they don't do fixed income directly with the interbank market or with the wholesale markets, because there is always like an intermediary, so that we go through like the banks or security house or insurance companies or asset managers to purchase the fixed income related products, right? But here in DeFi it's different, right? So we actually have a direct access. We allowed like permissioning from retailers and also institutions. So I think the big difference is like we need to create something actually easy for retailers to understand and to use. But at the end of the day, I think for fixed income, because of the nature of the product, you still need like institutions to help to push. Like, or for example, like ETF, right? So we have to have institution help to push to get the different level. So same as the fixed income, right? If we can like extend the yield curve, right? You can get the yield curve up to like 6 months, 12 months, or 1 to 3 years of like interest rate on ETH, on BTC. Then you will have a different scope of DeFi markets, right? So I think this is something that we wanted to build, and also the key difference is like the fixed income, we have to go to peer-to-peer or the book or the auction process, because it's not like the swaps or perpetuals that, for example, if you think of the bank's savings account, you put your money into the pool, right? And then some people have an OD account, like overdraft to borrow from the bank, right? The bid offer is wide. Or if you can think of like you put like 4 billion in Aave and somebody borrow 1 billion from Aave. What does that mean? That means that the interest rate they paid by Aave for the 1 billion, let's say for example is 4%, right? The depositor only get 1%, right? The capital inefficiency on the pool actually make this the fixed income it's very difficult to work. So it has to be the peer-to-peer for fixed rate borrowing and lending. So I think that's the fundamental the characteristic of the instruments make it like the peer-to-peer efficiency much easier to understand against the swaps or futures.
Got it. Got it. Yeah, thanks for sharing. Since we are all talking about like barriers and difficulties to that, let's talk about like more much happier stuff. Like, so what do you guys see as the most interesting part coming to DeFi in the near future, or at least in the foreseeable futures within just like 5 years? Yeah, let's start from Tom, since you're like, yeah, since the option is like more complicated or more complex than it's built on top of in DeFi space, instead of like lower hanging fruit like DAX or money market, right? So yeah, what do you see as very interesting in the future?
Like what I said before, I think the improvement of the L2 and the speed of the enhanced, actually, I think there is a big improvement from in L2 for the gas after Duncan upgrade. So I think this improvement and will decrease the barrier for the users to use L2. From the very beginning, we use L1 chain, and if you sign a transaction in Roma, maybe it costs maybe $20, and but it only costs maybe 0.1 cent now. So I think it's very good, and also as I mentioned, if the AA account and paymaster, you don't have to prepare ETH for the gas, and I think the user experience improves, and which will attract more people to use the DeFi, and that will happen in the near future.
Got it. How about Linux? Because like OKS is probably the newest compared with the others. Like you recently just like started tapping into DeFi and I want to expand more. So you probably be more optimistic about the space. And how do you see the space? And then what's interesting that thing or next things that will be integrated into OKX as well?
Yeah, I think the best role for OKX to play is to sit between central exchanges versus DeFi, decentralized space. I think we are reaching a massive scale that's whether or not we can somehow bridges in regulated manners that in some portion of some components of DEX or decentralized space, DeFi, that can somehow be introduced to under regulated space. So we can tell you that regulation is always coming, and I'm sure that you can't hide forever. That's because permissionless is decentralized, so there's no regulation coming in place. No, the question is whether or not the regulators have whether or not the sufficient understanding of which element that defines to be regulated. And OKS happened to play a role that we got the license all over the places, and whether or not we can introduce at least some portion of the DeFi to regulate space. I think that's massive. That could be massive to bring in regulated capital into this space.
Got it. Yeah, the regulation is another thing that would be like the next very important things in the space, and everyone will face that. Yeah, do you want to comment on the news last night about like OKS removing gonna remove all the Indian users? Oh, no, just kidding. No. So what's like Rain's or like Temple's or Jared's views on the interesting part, because like from my perspective, let me get also share a little bit about like my opinions on this, because like it seems like it's been a while after DeFi 2.0. There's no new breakthrough in the space. Like, oh yeah, you will probably see a lot of like new perps DAX every day and using a little bit different mechanism, but most of them are just like competing the same liquidity, basically, right? Or there will be projects like, okay, saying that, okay, I'm doing like options related stuff like options votes or options AMM, like there are more and more of that. And then, but eventually they will pivot themselves into like options perf or something, right? So yeah, I'm just curious because like I still don't have an answer right now because like what's the next innovation that, or what's the next experiment that we can do on chain from the derivatives perspective? Probably like 0.5 options, something like that, or what Pranoptic is actually exploring right now. Yeah, do you guys have any opinions or any idea or thoughts that could share with us?
Actually, yeah, you're right. I think like most of the perp DAX right now, we compete on points or airdrop. So like just depends on the airdrop. Like you can attract people definitely, but that will not last long. And to me, like there are like many new projects like really interesting, like Infinity Pool. They have this like you can leverage up, but you will not be liquidated. I think that's given design and like baseline the same. You can leverage up, you will not get liquidated. I think like a lot of this concept actually like kind of evolved from Uniswap v3, like the SYK model. I do think that that's probably like one of the breakthrough that if we only look at on chain, like I do think that someone can make it, like Penarchic, also a good example. Someone can make it, really working for the retail. I think that's the key. So there are definitely new mechanisms, just like it's just too hard to understand. It's just like they are like certain, you have to like use it in certain situation. But once we have enough knowledge that we can solve that, then I think that will be a breakthrough.
Got it. Yeah. How about Jerry? Because like you're building fixed rate thing. Like you're also like exploring this field with like bringing a traditional finance things on chain, right? And then it's from what we claim, it's still like lacking in space and not so many competitors. So you definitely will have a very like great thoughts that could share with us.
Yeah, I think definitely increasing the new use cases is the most important things. I think we expect the DeFi space to expand, right? So right now we've seen even like just like I mentioned earlier, the volume was traded like a double, triple, even 10 times. But what is the use cases, right? So and then of course if we just take one step back and then look around, like what do we want our like descendant to use the blockchain, and what do we want them to find this to live with that, right? So we want we want them to have like a real estate, also on-chain asset at the same time. So everyone on the street, they have a real estate, they have an on-chain asset, right? They manage asset liability, they match their duration of all this, their own balance sheet for the corporates, for the institutions, or even for individuals, right? So I think this is the key thing. How do we get there, right? We needed to get there with the, of course, the most important is the fundamental infrastructure technology on this, the blockchain that we are all mentioned about, right? There's all like UI, UX, all TPS, all this, all the different the process that we can L1 or L2 or even L3, right? So we know that it's not going to compete with the TradFi's efficiency, but it has to be somewhere that we can reach out. So I think this is something that I believe that this is the most interesting part we see in the future is that you're getting more like a mass adoption on this on-chain assets to everyone.
Got it. What? Okay, so how about Lennox and Rain and Tom? Do you think like what's the next interesting or derivatives that you see in this space? And probably yeah, probably it could just be like theoretical or something like a RWA based like YAS tokens or baseline things. Like yeah, sounds like yeah, probably crazy or probably just there. Yeah.
Yeah, from my perspective, I've been in TradFi for 10 years or so before getting into crypto. But a lot of the innovation can just happen from utilizing what's worked in TradFi and adopting it to crypto, right? Some of the, and adding in a few components, right? Like the decentralization or the user participation of it, like AMMs, right? Or like Perpetual or GMX, right? Like the user participation of it into the product, right? Using the blockchain instead of centralized databases, right? Like, I mean, in our case, we have a chain just to settle trades. Like, why can't that replace CME clearing, say? Why is our clearinghouse is not just on the blockchain, right? It should. And I mean, it becomes somewhat obvious for some of these, like what we call innovations in crypto that came from TradFi, but there has to be adoption, right, and really leveraging the blockchain. So I think a lot of that is interesting. And I mean, options is a small space, it's huge in TradFi, like fixed income, right, all of this stuff. And I think it's all coming, right, and even the RWA stuff. So like, I think there's a ton of, it's just like, so basically, I think my formula is the TradFi concepts and markets, reshaping that demand and product to CFI or DeFi, fully utilizing the blockchain, figuring out how to get users to participate in everything instead of us selling product to users kind of goal, right? And also adding in tokenomics that really reward all the contributors, which is what Web3 is supposed to be about. And there's going to be very interesting stuff that gets built. So yeah, that's my perspective.
Yeah, I think I don't see why the traditional asset class in finance that cannot be tokenized. I think everything can be tokenized, especially fixed income. So if think about that, if think about let's say 30% or 50% of current crypto assets is actually with the underlying of based on the underlying of traditional asset class like treasury bonds and different kind of debt instruments. I think that substantially increase the portfolio of the entire DeFi space. And because of DeFi, the accessibility of those kind of assets will be substantially increased and massive adopted in global scale. So everyone can just hold a tiny piece of treasury bills, even the fact that without the minimum amounts of holding at the moment. So I think that's what we call the real financial inclusion. Right now, the current obstacle for tokenization of these kind of access probably is only related to regulation. And right now, the regulation is keying different kind of roadblocks. So I think that's gotta be much more exciting the current trend.
Got it. So do you see that if the regulation gets clearer and clearer and being more certain, so do you see the situation will be better?
Very easy. So the very first roadblock that we're clear in terms of regulation is what is Bitcoin, right? What is Ethereum? And how to trade, whether let's trade on OKX or trade on Central Exchange, or how to custody this kind of wallet, this crypto asset. The next step of crypto regulation got to be related to tokenization of US dollar, tokenization of treasury bonds, tokenization of, I don't know, what kind of national debts. And that, if that can tokenize, so why not put in Uniswap, AMM model on trade in global scale? So probably in less than 2 or 3 years, somebody from India can have a crypto wallet, OKX wallet, and buying a 80% portfolio holding treasury bills in US.
Yeah, that's a really great point. How about Tom? Because like option is definitely in the frontier of advanced derivatives.
I'm very happy to see there are so many innovative and interesting projects on blockchain, such as Baseline, ETH token. And also there were many stable coins, calculation stable coins, but they failed. So in Roma's point of view, we may not think a new idea and just write it to the smart contract and release to the public, because someone may lose money inside, and I'm not happy to see that. So, but we will see the successful experience from other projects and take the good part and to our new project. So I think that's what I think.
Got it. Yeah. Thanks everyone for sharing this idea. Let me conclude this. So it seems like for building on-chain derivatives, still having a lot of hope, right? We definitely see there will be so many coming difficulties and barriers, and it seems like from the infrastructure perspective, yeah, the performance part, right? We are waiting for the performance to catch up. Like from an application level, we can also see that there are a lot of progress around probably intent or AA actually making like more abstract the blockchain part more. And we also see that like from after regulation got clearer, probably like the regulated liquidities will come in and actually can solve like most of the problems, since like liquidity is always the problem. So yeah, it seems like you still are having a lot of hope, and then hope our audience also enjoying this panel. And yeah, thanks everyone for like joining this panel. And then let's give all of the panelists a great applaud. Yeah.
Thank you, June, and thank you, speakers. We're now going to take a quick break for tea time. We have a happy hour sponsored by Orderly. I heard celebrations. So yeah, make your way to the happy hour, and then at 4 p.m. we have Gyroscope and Eidos Finance next. Take it away, Josh.
Awesome. Thank you, thank you. All right, hey guys, welcome to Elliptical Eccentricity for Capital Efficiency. My name's Josh, I'm part of the core team at Gyroscope, and we've recently launched a stablecoin, GYD. And part of the stablecoin system, we created this whole new automated market maker called ECLP, the Elliptical Concentrated Liquidity Pool based on an ellipse. And that's the topic for this presentation. Okay, so in this talk, I'll be going through a brief refresher on the evolution of automated market makers, AMMs, where we'll explore the ECLP's predecessors and their benefits and drawbacks. Then I'll present the ECLP itself, how it fits within the AMM, the evolution of the AMM design, and how it provides unparalleled benefits in specific use cases. And I'll show you how to construct one from scratch. And finally, I'll discuss the use cases of the ECLP, where it really shines as a value-adding novel innovation because of its flexibility. Okay, so first, a refresher on automated market makers. I'll discuss three main AMM designs: the original XY equals K, stable swap, and finally Uniswap v3, concentrated liquidity. So though automated market makers have existed for some time, the use of a constant function market maker where trades occur along a trading curve and is subject to some invariant constraint first arose from a blog post written by Vitalik in 2017, where he discussed why this property called path independence may be desirable for an AMM. The price quoted by the AMM is dependent on the quantity of reserves of each asset only, and not on the number or magnitude of any intermediate trades. So this helps to prevent any bleeding off of reserves caused by malicious actors. The peer-to-pool model of the AMM, the automated market maker, means that prices are algorithmically determined by some invariant function, and reserves are maintained within the AMM smart contract itself. So this has the benefit of allowing constant and permissionless access to liquidity and open and transparent determination of prices, as opposed to the peer-to-peer model, where finding the relevant liquidity to settle trades can be a little more troublesome. However, liquidity providers, LPs, who provide the reserves required for AMMs to trade can suffer losses if the relative price of the two assets diverges from that at which the LP provided liquidity to the AMM pool. So this is commonly known as impermanent loss. When designing any AMM, a careful analysis of the incentives for liquidity provision is required in order to make sure free agents, that is the LPs, the liquidity providers, are incentivized to provide liquidity and ensure that the AMM is actually useful. So impermanent loss is the loss to liquidity providers due to price variation relative to just holding that same set of assets. It's caused by the AMM not knowing what the external market price is. And so when the external price changes, the AMM is stuck quoting the stale prices and must be re-equilibrated to the market price by arbitrageurs. But arbitrageurs are not selfless individuals. They do this because they gain some profit, and this profit is the liquidity provider's loss in the zero-sum game of trading. So this is actually a form of adverse selection, since there is information asymmetry between the arbitrageurs or traders and the AMM. The traders know the true market price of the trading pair, but the AMM doesn't. So it's possible to mitigate this by allowing the AMM to react to some external price source, but then this introduces other sources of risk, like oracle risk, which need to be added to the incentive design formulation. Okay, so let's turn to the AMM's pricing function and how it can affect capital efficiency and slippage. So first we have Uniswap's constant product market maker, otherwise known as XY equals K, where X and Y are the quantity of the reserves of each asset, and K is the constant or invariance. It was the first AMM to bring Vitalik's ideas to production in November 2018, and also the first to enjoy significant volumes. Actually, Uniswap v2 was so successful that trading volumes sometimes surpassed centralized exchanges at the height of DeFi summer in 2020, and helped spark a whole new wave of DeFi innovation. The constant product market maker was an instance of the more general constant function market maker, which prices trading pairs implicitly via a constant trading function, which takes as input the reserves of the trading assets and constrains trading to a level curve according to an invariance. As the first significant AMM on Ethereum, Uniswap demonstrated that the idea of CFMMs worked. Relative to traditional order book market making methods, the AMM was faster as it had liquidity available on demand, and it doesn't have to wait for limit orders to be published and filled. However, the nature of the invariant curve XY equals K means that the liquidity is reserved for trading across the entire price space from 0 to infinity. So this is good for guaranteeing trade volume at all prices, but thinly spreading liquidity over the entire range leads to increased slippage caused by each trade, increasing impermanent loss and resulting in low capital efficiency. So then the next design question is it possible to focus liquidity into a range, since many trading pairs fall within a given range, particularly stablecoin pairs? So next up we have StableSwap from 2019. Curve came up with a solution by combining both the constant product and the constant sum market makers to create a hybrid market maker. So on the diagram, you can see how the trading curve reflects the constant product trading curve at the extremes of the trading range, but becomes closer to the constant sum, like a linear line, a straight line, in the middle. So since price is the derivative or the gradient of this trading function at any given point, the StableSwap curve quotes a constant price of 1, which then exponentially increases or decreases as you move sufficiently away from 1. The stable swap function also has this amplification coefficient parameter A. The lower it is, the closer the trading curve is to a constant product, and the higher it is, the closer it is to a constant sum. So this parameter allows curve pools to cater to the capital requirements of individual markets, instead of the one-size-fits-all approach of the constant product curve. So this means that stable swap is an excellent solution for price-related trading pairs, such as stablecoins and staked ETH, where prices are expected to remain within a finite band around 1. Since having a linear trading curve and constant price around the price of 1 means that stable swap benefits from extremely low slippage trades within that flat range. However, it also provides liquidity for trades across the entire price range, leading to capital inefficiency for the same reasons as a constant product curve. Then in May 2021, Uniswap v3 was launched. So it represented a large advancement in AMM design by introducing this concept of concentrated liquidity. So this means that liquidity providers could specify over which price range they wanted to provide liquidity, in effect gaining a multiplier on their provisions and leveraging their positions. So this has the dual benefits of both increased returns for liquidity providers and reduced slippage for traders within a specified price range. The downside is that when prices fall outside of this range, there's zero trading activity and therefore no fees accrue to the liquidity providers. However, as mentioned earlier, this may not be an issue for related trading pairs. In Uniswap v3, liquidity providers can open multiple positions with differing multipliers across the trading range, and thus they can combine these positions to custom tailor their liquidity provision profile as they see fit. They can also alter the profile dynamically in response to changes in market circumstances. The issue is that this active position management introduces complexity which the average DeFi user may not be able to or may not desire to handle. And also, since liquidity provider positions in Uniswap v3 are unique, users are given an NFT instead of an ERC20 LP token. So fees are not automatically fed back into the pool, and therefore they don't compound automatically, as with the previous AMM designs. So, is it possible to combine the capital efficiency of Uniswap v3 with the minimal slippage within a given trading range of stable swap? Can we provide liquidity within a range, in other words, concentrated liquidity, while also maintaining the ease of use and minimal position management of stable swap? Can liquidity providers get higher fees and can traders face lower slippage, while also ensuring that fees are added back into the pool and are auto-compounded without any required intervention? And the answer to all these questions is, of course, yes. So enter Gyroscope's elliptical concentrated liquidity pool, the ECLP. Okay, so Gyroscope's brand new elliptical concentrated liquidity pool represents a step forward in AMM design and innovation. The trading curve is actually part of an ellipse that is constructed by applying a series of linear transformations on top of a circle. First, we take a circle centered at the origin, we stretch it, rotate it, and finally shift it. The trading then occurs on the part of the ellipse which is monotonically decreasing. The ECLP provides pool constructors a greater number of parameters to tinker with and optimize the shape of the trading curve for optimized capital efficiency in the specific market use case. So let's construct an ECLP trading curve ourselves and see how changing the parameters can optimize the curve for certain use cases. Okay, so we start with a circle centered on the origin, our classic x squared plus y squared equals radius squared. The circle is then stretched into an ellipse by the factor lambda, and you can see the corresponding matrix which represents the linear transformation. Then the ellipse is rotated anti-clockwise by angle phi. Again, the linear transformation is here in the corner. And finally, the ellipse is translated by some vector AB. So the origin is now at AB. So as you can imagine, the combination of all these parameters, the stretch factor lambda, the rotation angle phi, and the translation vector AB, provides a ton of flexibility with which to optimize the ECLP to particular use cases. So for example, stretching the ellipse or increasing its eccentricity means that the final ellipse has a broader, flatter area, which results in lower slippage trades, similar to the stable swap design. Rotating the ellipse can increase or decrease the peg price around which the slippage is minimized, and shifting the ellipse allows the constructor to alter where it intersects the x and the y axes, or in other words, to change the price range over which the ECLP accepts trades. So the ECLP provides concentrated liquidity similar to Uniswap v3 by constraining trading to within a trading range, alpha to beta. The prices alpha and beta are determined by the slope of the ellipse where it intersects the x and the y axis, as you can see here. The next interesting parameter of the ECLP is the peg price, which is the price where the ellipse is at its flattest, and it's also the price where there's the least price impact. Note that the peg price doesn't have to be symmetrical about 1, unlike in StableSwap, because of our ability to translate the ellipse anywhere and rotate it. So this is super helpful in use cases where perhaps you want most liquidity focused in the upper bounds of the trading range, but you want to reserve some capital for lower probability cases nearer the lower bound. Mathematically, the peg price is calculated as the tan of the rotation angle phi. To see this, note how the peg price gradient line, when extended, makes angle phi with the x-axis. Interestingly, the peg price doesn't even have to lie within the trading range, such as in this diagram. In this case, the price impact of a given trade increases as you move away from the peg price. In other words, the convexity of the trading curve increases as you move away from the peg price. And this can be useful where you want most liquidity focused at one end of the trading range. So now you can understand what the key parameters are in our UI for the ECLPs. We have alpha, beta, the price constraints, the peg price, and lambda, the stretch factor. Okay, so let's discuss some of the benefits of the ECLP. First, liquidity where you need it. So unlike StableSwap, the ECLP's asymmetric price ranges allow it to unevenly distribute liquidity within its finite concentrated range. So for example, where prices are bound from above by 1 and from below by 0.5, but are expected to trade mainly around 1, the ECLP can unevenly distribute liquidity at the upper end of its trading range. Using the curve of an ellipse allows highly customizable liquidity profiles. In fact, the ECLP can be calibrated to approximate almost any trading curve that would be desirable. Another benefit, low operational burdens on LPers. Unlike Uniswap v3, all liquidity provided to ECLPs are within a single given price range or a single tick. So this means that liquidity providers don't have to actively manage their position between ticks, making it easier to passively manage their position. Setting the shape of the trading curve on initiation transfers the burden of liquidity profile management to pool constructors and away from liquidity providers. In Uniswap v3, with extreme flexibility comes extreme responsibility, and thus liquidity providers are required to set their own liquidity profile by combining v3 positions. And this may be great for sophisticated market makers, but for most DeFi users it's not really practical. No need for active position management avoids this arms race between liquidity providers as they scramble to update and optimize their positions with new market information. This also reduces the barrier to entry for liquidity providers. Just join on our Gyro UI and let the ECLP do the rest. So Gyroscope's ECLPs marry the user experience and simplicity of StableSwap AMMs with the benefits of concentrated liquidity of Uniswap's v3, the best of both worlds. Okay, rounding things off, we'll talk about the ECLP's use cases. So the ECLP is currently heavily featured in the Gyroscope ecosystem. In the secondary markets for the GYD stablecoin, where trading is expected to occur between the price bounds set by the primary market's mint and redeem quotes, liquidity can be concentrated around the peg level of 1, but some can be unevenly distributed at lower levels for niche situations where the redemption price is at a discount. So unlike StableSwap, liquidity would not be provided by the ECLP above the price of 1, where no trading is expected in the secondary market. And this is because arbitrageurs are expected to mint at a price of 1 and sell in the secondary market, ensuring there's that upper bound at 1. Also, in our reserve vaults, concentrated liquidity means that there's increased swap fees caused by trading activity between the stablecoin reserve assets. And so this helps to bolster the reserve health in the long run. The reserve vaults are currently implemented in the Gyro dynamic stability mechanism, and one of the reserve assets is the LP token to our LUSD CurveUSD ECLP. Actually, the GYD stablecoin and the ECLP automated market makers have a rather symbiotic relationship. GYD aims to be the central asset within a liquidity network of ECLPs, providing low slippage, high capital efficiency trades between multiple assets in a network of AMMs, such as on Balancer. And the ECLP helps create an efficient secondary market for GYD utilizing concentrated liquidity. And LP shares for other stable pairs can be used as yield-bearing collateral and reserve assets for GYD. Okay, so in both Lido staked ETH and Liquity's LUSD, trading occurs in a specific range bounded by the mint and the redeem prices of the derived assets. Again, there's no need for liquidity to be maintained outside this trading range. So the ECLB can be calibrated to concentrate liquidity to fit the market conditions. Benefits over StableSwap, as mentioned before, include not wasting liquidity provision in parts of the trading range that should never occur. So for example, above the mint price or below the redemption price. Pool creators can set the pool parameters upon construction to optimize liquidity provision, given current trading market data and any other factors such as tokenomics, which could affect the price and trading activity of the pair. So another huge benefit of ECLPs is our use of rate providers. So what happens to an AMM when one or more of the trading assets are yield-bearing tokens? So for example, between Lido's wrapped staked ETH and wrapped ETH. Wrapped staked ETH is designed to keep your balance fixed while your balance of the underlying staked ETH increases over time. As discussed earlier, we expect that the external market price changes, driven in part by this yield, the AMM price becomes stale and is only brought back into equilibrium by arbitrageurs. However, the arbitrageur's profit is the liquidity provider's loss. So to reflect the yield and the changes in prices, liquidity providers in other concentrated liquidity pools will have to actively manage their position, manually shifting their desired liquidity distribution. In contrast, ECLPs use external rate providers, which allow this yield to be endogenous to the pricing model. So in other words, as you can see in the animation on the right, the liquidity distribution of the ECLPs with yield-bearing assets shifts to the right over time, as the yield naturally changes the relationship between the assets of the trading pair. So this prevents the need for arbitrage, allowing the yield to end up with liquidity providers instead. So this is great news. Liquidity providers can rehypothecate their yield-bearing assets and add liquidity provision yield and other external incentives to gain some juicy cumulative yield. In fact, just this week, we've teamed up with Aave to launch the brand new Aave Rehype Pool, which allow liquidity providers to provide Aave static A tokens and enjoy the yield from Aave lending, the yield from AMM liquidity provision, external third-party incentives for liquidity provision, and brand new gyroscope spin points. And they're all available on our UI today at app.gyro.finance. Okay, so in conclusion, ECLPs, elliptical concentrated liquidity pools, combine the user experience and the auto-compounding of Curve's stable swap pools with concentrated liquidity and asymmetrical liquidity distribution from Uniswap's V3 concentrated liquidity. So with a ton of parameters to choose from, ECLPs provide a customizability for specific use cases. And they're already being used today with stablecoins and LSTs and have over $25 million in total value locked. In the future, we plan to add updatable parameters to our ECLPs to allow for a more dynamic ECLP. The ECLP is integrated with top order routers such as Balancer, 1inch, and OX. The smart contracts are audited by leading names in the industry, as you can see here. And the gyroscope team is supported by some big players in the DeFi space. Okay, so that's the end of my presentation. I'll leave with this slide summarizing the differences between some of the different AMMs I described, and perhaps we can have some questions.
Thank you. Does anyone have any questions?
Hello, good to see you. And I have two questions. The first question is about mathematical. Because of the curve you said will be oval, and is that the phi be 45 degrees?
Will the phi be 45?
Yeah. Maybe or not, I'm asking you, because if the phi be 45 degrees, it will be a circle. It's the first question for this type you talk to me. So I'm asking you the phi is be possible in some ways or some situations be 45 degrees. Yeah.
Yeah, so the phi is a variable, so you can change it as you like. If the ellipse was a circle, then obviously the phi wouldn't, the angle of rotation wouldn't matter. But since it's an ellipse, the angle of rotation allows you to change the peg price, the flattest part of this ellipse. If it's 45 degrees, then you get a peg price of 1, tan 45, right? But you can still change it so that it could be more than 1, less than 1, however you like.
So it always be changeable, in your contract, yeah, in your smart contract or something?
So right now it's static upon pool construction, but we're working on dynamic ECLPs where these parameters can be changed and updated.
Oh, thanks. And the second question is about the sandwich attack. Will sandwich, I believe it still have some sandwich attack, but the sandwich attack will get bigger benefit in this new type of the pool or not?
Right, so we're currently building on top of Balancer. And one of the aspects of Balancer's vault is that you have to specify a minimum or maximum allowed slippage. So this helps mitigate sandwich attacks, because if the price is too far away from what you expect it to be, then the transaction just won't go through.
Okay,
does that answer the question? Okay.
Thank you.
All right.
Thank you. We have one more question over here.
So with the update for ECLP, would there be a pool manager, something like that?
What, sorry?
A pool manager?
A pool manager?
Yeah, to update the parameters for the...
Right, yeah. Yeah, I assume so, because once the parameters become mutable, then yeah, we'll probably create a user interface for users to tinker with their ECLPs as they like.
Do you have any plans, like how would this manager be chosen, or it could be a type of auction, something like that?
As in, who has permission to change the... Yeah, I'm not too sure on the plans right now. I mean, it could be just the pool constructor, or it could be a certain permission which could be transferable. But yeah, there's lots of options available there.
Okay, thank you.
Nice.
Thank you, Gyroscope.
Thank you.
Next up, we have Terrence from ITOS Finance. All right, are you all very excited? This is the last talk of the ETH Taipei conference. Please welcome Terrence from ITOS Finance.
Nice. Hey guys, so I got a little bit of food poisoning last night, so I'm gonna, just please bear with me. If I need to take a pause, that's what I'm doing, not contemplating about life or anything. Cool, so this talk is about DeFi Math 102, just a little step up from the things that you might be familiar with in DeFi. And particularly, we'll be talking about how to construct token derivatives, whichever one you want. So quick background is I used to work at an HFT at Hudson River Trading. So my background is a lot in thinking about market microstructure and not so much the macroeconomics, but that makes me really suitable to speak about how we design these small DeFi systems. Right now I'm building Ethos Finance with 2 other people, and we specialize in creating these things called token derivatives, where you can think of it like this engine that you put in a token and then you get out a separate payoff that is derived off of that token. So for example, I can put in normal BTC and suddenly I might get like an option on BTC or a future on BTC. And those are the two basic ones, but we can go crazy with it. We can start guaranteeing token floor values, we can prevent liquidations, reduce volatility, really get some nasty stuff that maybe you've never even heard of unless you are in wealth management or are very wealthy yourselves. I don't know, maybe you are. I hope you are. So the reason that this is different than previous attempts at structured products is the previous attempts all use an off-chain underwriter and they bridge the asset over. And so users buy it from a vault, it's usually priced by a sophisticated underwriter, and that really means you're just getting adverse filled. Like from day one, you have negative expectancy, and that's not great. You have lockups, you have an expiry, and you have manager risk. Like all these things make vaults a terrible experience. What happens now if you derive your structured product entirely on-chain, your counterparty are DeFi native money markets, DeFi native AMMs. Anyone can build, mint, and use it within seconds. There's no one you have to talk to, nothing you have to worry about. There's no lockups, no managers, one smart contract transaction, and you're good. Cool. So just to be clear, this is a 102 talk, which means I won't go through the, it won't be too advanced. There's no, you don't need to worry about finance or whatever background there is. It's mostly just gonna be pictures, which is great, everyone loves pictures. There is no pricing information here because honestly, once you get into stochastic calculus, it's very hard to come back. And that's just not what this talk is trying to do. But feel free to talk to me about it afterwards. And especially once you get more advanced, the theory and reality really breaks down. So I didn't want to talk about things that have a lot of qualifications to it. Rest assured, everything we go over today is 100% true. You can rely on it to build your own protocol, to invest, whatever. It won't be too basic at the same time. I think Josh did a really good job covering AMMs, so I'll be super quick about that. There's plenty of DeFi users here. There's so much existing material. I'll do a super fast recap, like the fastest you've ever seen. And I can't do 101 because Taipei already has a 101, you know? Like, who can compete with that? So today's lineup, we're going to be talking about 5 techniques you can do to build a structured product entirely on-chain. What this new version of structured products is going to look like. They're going to be rotation, reflection, composition, scaling, and integrations. And with each of them, you have a different type of payoff we can make. So before we begin, here's my quick recap of AMMs and LPs. It doesn't matter about the market making, it doesn't matter about the range, forget all of that. The simplest explanation of an LP, a liquidity provision position, is you sell the token upside for yield. That's it. Over in the future, we might design new AMMs, like Josh has different curves. All of them have one fundamental property, and that is you are selling your upside for yield. What this looks like is, here is a regular token payoff. If the price goes up, you profit. The price goes down, you lose. And once you LP, you get capped profit on the upside, and you still have your unlimited downside potential. So that's no fun because you're missing out on a lot of these profits, and we'll be talking about how to fix exactly those things. Before we move on from this, though, I do want to mention one property, that the capped upside comes from the negative curvature here, and we'll call that concavity. And one fundamental property of all finance, doesn't matter if it's DeFi or TradFi, is the moment you have negative concavity, you earn fees. Negative gamma, they might call it a billion different things, but there is fee earning or a yield whenever you have negative curvature. So one very natural question is, we have this LP position, can we kind of flip the side, right? Maybe I think the token is gonna go up, so why am I selling, or maybe I think the token is gonna go down, so I don't want that downside risk. So instead, let me rotate the position so I only have upside risk and no losses when the price goes down. Very natural position. And the way you do that is just with simply a short. That once we short in this example, ETH token into USDC, the combination of the two gives us this type of payoff. We still make fees in the same range, but we just have a slightly different exposure. And we can also short everything in between one end or the other, and so we can make a delta neutral position just by shorting less. Nothing crazy here. The one caveat, though, is you don't want to overshort. In this scenario, we shorted the 90-degree rotation by understanding the Uniswap v3 paper. I don't want to get into that, but it's a pretty straightforward formula. Once you overshort past 90 degrees though, the short dominates the position and you pretty much botch whatever you were trying to do before and you just essentially have a short position. So yeah, that's a simple technique of rotation, and it gets more exciting once we start talking about reflection. Now, how do we create the opposing curve, right? Maybe you're just sick of downsides. Why do we always have to have a downside with LP positions? What if I just want a position that is all upside? You know, safe on one end and only profits on the other. And mathematically, there's no reason you can't do that, right? Anything we create in code means anything we can describe with math, and clearly we can describe this with math. So how do we do this? Well, the answer is pretty simple, actually. We just have to reflect over the intermediary line. And so you can just draw the line and say, I want to short the LP position in return for these assets that are denominated by the line. And all of a sudden, I have my liquidity taking position that is only positive exposure. This is fantastic. And it doesn't have to be that line in the middle. You can use different lines. And so maybe you want something with more of a negative exposure. And with all of these, there is some floor value. So why don't we just subtract that floor value, add in some more capital efficiency, and voila, we suddenly have these options payoffs. And so we've already arrived at a pretty big step. You don't need SSOVs, you don't need off-chain underwriters, you don't need a limit order book to create options in DeFi. You just have to do a bit of math, and boom, you have your option payoff. The downside is, nothing comes for free. If you want all upside, there has to be a downside. And the downside really just comes from shorting that LP position. Because unlike shorting a token this time, shorting a position means you have to do the entire opposite. So whenever the LP position would earn fees, you have to pay fees. And that's a pretty fair trade-off, because I'm sure there's more than one person here who's LP'd for like 6 months, and the yield was definitely not worth the impermanent loss you got. And what if you could just take the opposite position, right? It's like that Wall Street bets thing. I keep losing money, well, just do the opposite of whatever you're doing. Literally that. So if you ever feel like the yield is too low, heck, take a liquidity taking position. And once we start combining this reflection and rotation technique, we can start doing some crazier things. I narrowed down the market making range to be really small, right at the current price, rotated it by 22 degrees, and all of a sudden you have a bidirectional perp, meaning whichever way the price moves, you profit. The exact same way a perp would, but now you pay a slightly higher funding rate as long as you're sitting in the middle. So that's a pretty good deal when you're just trying to bet on volatility and you have no idea which way the price is going to move. Probably like right now. And it gets even crazier once we start adding cross margin into it. This is really where we start touching on insanity. Because we have all these positions before and we can combine them into insane things. This is just a random position I decided to create because I could. And Mr. Bones' Wild Ride is made by all these different positions underneath it. And the way to construct this thing, the way I went about it was I just thought about where do I want positive and negative curvature. That is where I'm going to create my market making, market taking ranges. And then on either end, what do I want the first derivative to look like? Depending on that, I can short or rotate accordingly. And boom, within 5 positions, I've created a roller coaster of a payoff. But you can make more useful things. It doesn't have to just be like meme payoffs or whatever. If I want to fix LPing, one of the worst parts of liquidity providing Uniswap v3 is that once you go out of range, you stop earning fees, but you still continue your losses, right? If the token is just going down, you come back in a week and you're eating all of those losses without earning anything. So a very natural thing is the moment I go out of range, let me hedge out my position, not worry about it. I can come back in a month, I can come back in a year. There's no risk to me. So it's a much more user-friendly version to LP. And we don't have to stop there. We can make a delta neutral version of this, applying the same techniques we already have. Heck, we can even start doing more degen things where we're like, I want to make money in the extremes. I don't even just want to hedge. And we can ramp up the 2 liquidity taking positions on either end as much as we like. We can compose it however we like. Really, at this point, the possibilities are endless. Literally, whatever type of curve you want to create, doable entirely on chain, no permissions needed. Forget about TradFi, we don't need them. My personal favorite, though, is actually this one, which is the token converging LP. This construction makes it so that in the short term, if you're just worried about the price right now and you want to earn yield right now, you can. it sells curvature at the current price. But if you don't worry about the token going up 1.5 or 1.7, you're holding until that token goes to 2x to 10x. The liquidity taking is structured in a way such that you reconverge back to the tokens line if it ever 2x's to 10x's. And honestly, that's like what a lot of people are holding for. So in a way, this is kind of what people originally thought LPing was going to be. I can just hold a token and earn yield on top of it. I don't have to think about impermanent loss. Great, so that's composition. What we did in composition was create a really safe way to LP. But let's be honest, like degens don't get out of bed for safety. No one is like, I want to be safe with my investments, let me go to DeFi, right? They want something exciting. And so how do we turn this into something exciting? And obviously the answer is leverage. The answer is always leverage. But what is leverage really doing? It is scaling our position. So the first thing we're going to do is notice we have a floor price. And that floor price means our position will never go below that value. So this is kind of capital inefficient, right? If the floor is that high, what if I just deposit less to translate the whole thing down, just like we did with those option payoffs? And we can. In this scenario, we're not just depositing less, we're actually depositing the whole LP position and then borrowing, which is effectively the same thing. And we suddenly have a way more capital efficient way to LP. But it's not just capital efficiency, because we can scale this baby up to roughly 300x LP, depending on the pair. It just comes down to what is the granularity of your AMM. And if your granularity is small enough, you can just keep raising that leverage. And at 300x LP, like, you can beat impermanent loss by just LPing for a single day, right? If you think the price is not because like Fed Powell isn't talking today, you're just like adding liquidity today and nowhere else. And you've already earned a year's worth of yield just by doing that. So we're super happy with this. We think this is like the most degenerate way to liquidity provide. We can go even more insane though. And that's not just with payoffs. Once we start integrating this with other protocols, we get some really beautiful properties in those other protocols. For example, if we wanted to add this to a borrow lending market, we can create liquidation-free borrow lending. With a single button, you can say, hey, I think volatility is too high. Open up all the positions, all the convex positions I need to make sure I never get liquidated. I can borrow and lend any token as collateral for any other token because, again, I can just use these convex positions to hedge that divergence risk. So like this utterly changes both the payoffs that we're interested in and the other protocols. You know, like we could have non-liquidating perps, and the list really goes on. Like these are just some of the things I thought about, but I'm sure like there are plenty of things I haven't thought about. And the list goes on and on. Digitals, roulette wheels, LST convertibles. Yeah, I won't even try to read all of them. But what really excites me is the implication of this. Like from a broader perspective, looking at the forest, for the first time in history, it's not a TradFi institution that is underwriting something for DeFi, right? Every time DeFi tries to do something more advanced, we have to go to TradFi and be like, hey, can you help us out with this? All of a sudden, it's not that TradFi and DeFi are creating the same structured products on par with each other. It's that DeFi creates more advanced, more flexible, more assets than TradFi. Like all of a sudden, the best place to go if you ever want a structured product is DeFi, right? And I don't think you can say that about a lot of markets. And the beauty of it is it just comes from math. One of my friends works at Goldman Sachs, and you know his desk regularly underwrites about $2 billion worth of structured products every month. And the only thing they're really doing is floor valued SPY, floor valued NVIDIA, floor valued Tesla. And that is so easy to make on chain. If you ever had an RWA for any of those things, you know, you don't have to go through an account manager, you don't pay them commission, you don't pay fees, you don't make 6 phone calls just to make sure you have the approvals to do it. One transaction, boom. Cool, so this is not just theoretical. We actually went out and built these things, and today is the first day we started uploading a lot of this onto testnet. And so you could go yourself to, oh no, where's my mouse? Bear with me as I struggle to, yeah. So what we can do is you can go to Ethos right now and get your IL hedge position, your real hedge position. It feels a lot like Uniswap. And we really just wanted to make a very degenerate version of Uniswap. Don't worry, the leverage bar is right here. For this pool, you can only go up to 20, but it depends on the pool. Maybe we'll redeploy at some time. And you can see that once you jack up this leverage, let's say to 10, you get 210 APR instead of whatever. But of course, the IL risk is higher. So nothing comes from free. We're not trying to make any shticks. We're just trying to do a bunch of math and the flexibility that comes with it. Cool. This is permissioned right now, but you can go mint yourself test tokens today, just on the website, testnet.ethos.fi. And I want to be clear that it's not as simple as just doing these equations. We had a lot more to solve, and honestly, these were much harder than the things that I talked about today. And so, unfortunately, we don't have time to go through it. But you have to think about ideas of what is the fair trading fee rate, and that gives you an implied volatility premium. The hardest one is by far, how do you implement a fair liquidity borrowing rate? Like, what is the corresponding time premium you can derive from options and translate that over into what liquidity taking should be. Honestly, everyone knows the right answer to that. Everyone in finance knows the right answer to that because you can create a box spread and you would know what the implied lending rate of these things should be. But what is a box spread in DeFi and how do you implement that corresponding interest rate? Finally, we have to make some really safe and user-centric cross-margining. That is not a simple deal at all. And how do we present it in such a way that, most of DeFi is not as experienced as you guys, so how do we keep it simple and relatable? Cool, so we're nearing the end. What else is there to solve? We don't want to pretend that we have all the answers. There's still a lot more to do with just the math for DeFi is utterly unsolved. Continuous expiry offerings, how do I recover the expiry ideas from options, because those are indeed useful in a lot of scenarios. How do you make conditional liquidity providing, like only providing when the yield is sufficiently high? How do we butterfly the yield curve? The list really goes on, and if you're interested in these things or interested about building those things, please talk to us. So finally, we are Ethos Finance. We launched a lot of things on our testnet deploy today. It is still private for now, so you should follow our Twitter, go on our website, join our Discord, and keep in touch for updates. We are now raising a seed, and so if you're a builder, developer, DeFi user, investor, come talk to us. Cool. I hope that was helpful. Any questions?
If no questions, you do have their Twitter, and you can also find Terrence at after his talk, I guess. Thank you very much.
I guess I will mention that this also happens to be the proof of why, the composition aspect is the proof of why the Uni V3 curve, in my opinion, is all you need, because every other payoff curve can be replicated as just a combination of Uni V3 positions. So I think that's an interesting property, but there is value to having the entire curve be preset for you so that users don't have to think about it. Yeah, it's an interesting homomorphism between all yield curves. Cool.
Thank you. Sorry. Hello. All right, so that's it for ETH Taipei. Thank you everybody for joining us today. We're gonna start wrapping up and setting up for the hackathon that's gonna happen for the next 2 days as well. Thank you.